You may have to pull down this border right here to see it all. But every program block has this. And depending on what type of program block it is, it'll have different sections up here. So this is an organization block, an OB, and the sections we have are input, temp, and constant. And notice the input area is grayed out. We can't add any additional inputs. But the temp area, we could add tags here. And this really is sort of local. So these tags would only be local to this organization block. So in that sense, I guess we do have local tags in Siemens. But the temp there means that they are temporary tags. So any tag that you put in here that you define here, its value is not remembered in between scans of the PLC. So every time OB1 is called, any tag you put in temp, its value is reset to 0 or false or whatever the default value is for that data type. It's temporary. And it can only be used here in organization block. And then we've also got this constant area. These are any constants that you need. The value of that tag never changes. And again, it's just local to this organization block. So this is always up here. All right, and notice I don't have anything defined up here. There are no tags defined. This plays more important role later when we start talking about function blocks and functions. And I didn't mention it, just look at my screen here. If I go back to that global data block, glob controller tags, notice that it has a static area. It's called static. That's where all of our tags are defined. The term static there just means that the tag's value, it remembers what the value is in between scans of the PLC. You put a value in that tag, it's static. It stays there forever until you put another value in there, either through logic or through the HMI or through your programming software. It doesn't get reset in between scans of the PLC. That's the term static. All right, so let's take a look at network one. Remember, we said OB1 main is like main routine. So we should just see a bunch of JSRs here. So let's expand network one and see what we got in there. It says we're going to call the simulation function block. Let's see if that's what we're doing. Your zoom controls, if you need to zoom in, are right here. You can either use the drop-down box or you can use the little slider bar. I'm going to zoom in about 150% here. This is what a JSR looks like. Remember we said, okay, if I'm thinking routine in Rockwell, I'm thinking function block in Siemens, and this is a function block call. How do I know it's a function block call? Well, the %FB8 gives it away. That's the function block number. Now, I really don't care about the number. I care more about the name, simulation. But the software automatically assigns a function block number. Remember, we also said that function blocks have local memory. That local memory is stored in what is called an instance data block. Now, we talked about a global data block. Those are ones that you create. Think controller tags. An instance data block is the local memory for the function block. It'll always be there. Anytime you call a function block, it's got to have an instance data block on top of it. It's got to be there. And it gets defined out here in the project tree. You can see it right there. All right, so yep, this is what calls all my simulation logic. This is where I've got, if you open up the steam valve, then the temperature in the tank starts to climb. I've got all that buried in this simulation routine function block. All right, let's look at network two. Also a function block call. This is my analog input handling. This is what sets my scales, my analog inputs, and checks to see if we got a high alarm or a low alarm. Because it's a function block call, it's got to have an instance data block. It's got to be there. And my naming convention When I create it, I precede the name with INST, or I prefix it. That comes from that programming style guide I showed you earlier. That lets me know that it's an instance data block and not a global data block. But it automatically gets created for me when I use this function block. Let's look at network 3. This one's a little more complex, let's say. So this is, again, a function block call. Notice %FB1, I'm calling my mix tank sequence. Instance data block's got to be there. There it is. But look at all the inputs that I'm passing in and outputs that I'm getting out. This looks more to me what I would call an add-on instruction in Rockwell. You define your inputs, you define your in-outs, you define your outputs, and you call it over and over again. And indeed, we could do that. If we had another mix tank that was exactly like the first one, we could just reuse this function block and then tie in the different I/O. You know, a different temperature transmitter, a different level transmitter, a different valve position. But we said, if I'm thinking routine in Rockwell, function block. So this here is a function block as a routine. And then we also said, if I'm thinking add-on instruction in Rockwell, I'm thinking function block. And to me, this looks like a function block as an add-on instruction, a reusable block. Not for organization, more just reusable. Siemens really doesn't differentiate like Rockwell does. Let's close it out with network 4. Let's just see what that looks like. Again, 3 more function block calls, one for valves, one for fixed speed motors, one for variable speed motors. Notice each one of them has an instance data block. Got to be there. All right, but the upshot here is main OB1 is a lot like main routine in Rockwell. Typically what you'll find there are just calls to all the other functions and function blocks in your project. All right, easy enough. Let's look at function block as an add-on instruction. So again, I don't know how many of you have actually created your own add-on instructions versus modifying, troubleshooting, whatever it is, but hopefully everybody in here is at least familiar with the concept of an add-on instruction. But this is what gives us true object-oriented programming in Rockwell. It allows us to create an instruction that we can reuse over and over and over and over again. And so if we're going to look at the AOI for the valve, so AOIs in Rockwell are in a dedicated area under Assets Add-on Instructions. And to create a new AOI, and this is one version old in Rockwell, but it's very similar. When you create an AOI, the first thing you have to do is define what parameters you're going to send and get out of the AOI. So for the valve, I'm going to send in the closed feedback, the open feedback, the auto permissive. So if the valve is in auto, when should it open? When should it close? And then we talked about the interlock. Yeah, don't let the steam valve open if we have high temperature. All right, my HMI tag, notice I used the UDT here. Remember, that's what gives me my auto request and my manual request and all of that. And because I'm using a UDT, it has to come in as an in-out parameter. I'm both reading from that tag, but I'm also writing to it. Remember, the operator can request auto mode, so that would be an output. So the HMI comes in as an in-out. And then finally, our outputs, I'm sending the solenoid valve that tells the valve when it should open. And I'm also going to send the fault out. You know, maybe outside the AOI, you want to turn on an alarm horn or a beacon or something if the valve fails to move. Once you've defined your parameters, you then define your local tags. Local tags are just any tag that you're going to use inside the AOI that you don't need to pass in as an input. You don't need to pass back out to the outside world. It's local just to the AOI. And so I've got a fault timer here. If I've asked the valve to open, I need to wait a little while before I fault it. Got to give it time to move. There's my fault timer. And you never know when you're going to need a one shot. It requires some storage bit. So I just create an array of 32 Boolean. Now the PLC, Rockwell handles any tag you put in local tags. The value of that tag is remembered in between scans of the PLC. A timer wouldn't do us any good if it reset to 0 every time this AOI was called. It has to remember where it left off and pick up from there. Remember, in Siemens, we refer to that as static. But Rockwell does it for us automatically. Any tag we put in here in local tags, its value is remembered in between scans. Okay, we can then go and write our logic. And I'm not going to go through all the logic for the valve and the Rockwell, but we'll go through the first couple of rungs anyway. So rung 0, notice the rung comment, handle auto manual request from the HMI. That's exactly what this rung does. If the HMI requests auto mode, so if the operator requests auto mode, then we unlatch manual, we latch up the auto, and we unlatch the request. Handshake with the HMI. Or if the operator requests manual, then we unlatch auto, latch up manual, unlatch the request. If we're not in manual or auto, we should never get there, but it could happen, then we go ahead and we latch up manual. And then we handle the manual open request and the manual close request. And then right below that, rung 1, notice the rung comment is energize output. That's exactly what the rung does. If we're in auto mode and the auto permissive input is true, or we're in manual mode and the operator requests manual open from the HMI, our interlock is healthy, then energize the output and also let the HMI know that we've done that. There's some additional logic down there with the fault timer and the HMI status and all that. I'm not going to go through all of that. Once you've finished, got the logic written, you're ready to go. We then need to go use this add-on instruction. The fancy word is instantiate, but all it means is we're going to use this AOI for all of our valves. Now we only have valve 11 and valve 12, so we need to call this add-on instruction twice. One for valve 11, one for valve 12. And we said we could put all of our logic right here in main routine, but we don't do that. Instead, what I've done is I've created another routine called mixed tank valves, where I'm going to have all of my valve logic. All right, so if I go and I open up that mixed tank valves, here I've double clicked on the mixed tank valves routine. This is the function block diagram editor, by the way, if you've never seen it in Rockwell. But as soon as I drop that AOI down into a routine, the software automatically creates an instance tag for me. And I renamed it to something a little more meaningful. But every time I use that AOI, it has to create a tag. And it has to be unique for every time I call this AOI. Well, where does that tag get created? Well, only two places it can be, either in controller tags or local tags. You decide where you want it. But then you just tie in your inputs, your in-out, and your outputs. And then you do it for valve 12 as well. And if I go look in controller tags now, I've got two instance tags. There's the one for 11. Notice the data type is the name of the AOI. And there's also one for 12. And what can I see in that tag? I can see the inputs, I can see the outputs, but I can't see the in-out, and I cannot see the local tags. Rockwell blocks all of that. All right, so hopefully all that's just review for you. Developing an AOI and using the AOI. All right, so we said, what is the Siemens program block that is most like Rockwell's add-on instruction? And we said it could be a function block or a function, but we're going to really lean towards function block. So let's see if we can go find a function block named AOI SV. Let's see if we can go find that. Well, in Rockwell, we've got a dedicated area, assets add-on instructions, And we really don't have that in Siemens because Siemens doesn't differentiate between function block as an AOI and function block as a routine. It's just a function block. So what I did is I created a group folder here named add-on instructions. So let's talk just a little bit about these folders right here. Notice I got a bunch of them. Add-on instructions, I/O handling, motion control, motors, sequences, simulation valves. Again, I cannot stress enough how important it is to use these groups. Now, this doesn't set how it executes in the PLC. This is not like a program you would have in Rockwell. It is strictly an offline organization tool. Helps you to organize all your program blocks into folders that makes them a lot easier to find. Let me show you what it would look like if you didn't use those. So here on the left, we've actually used them. So this is what your logic looks like sitting in front of you right now. So add-on instructions, I/O handling, motor sequences. And here on the right is what it would look like if you didn't use group folders. Okay, well, where's my valve stuff? Where's my fixed speed motors? Where are my HMI tags? A little bit harder to find here because without the groups, it organizes it by block type. So all your OBs are up here together, all your functions, all your function blocks, all your data blocks, and then it's just alphabetical order. Harder to find stuff this way. So again, use these groups.
Question, Ron.
Question,
Great.
Ron. You mentioned earlier in the processing management that this processor is still what they used to call a drum or circular pattern. It's not asynchronous. So, and you just said that when you put these in these groups, it has no impact on how it runs.
Correct.
So do you as the programmer have control over how it cycles through these, or how does it?
It is the order in which you call them from main OB1.
Okay, that's the only way.
Yeah, yeah.
That's good. That's good. Thank you.
Yep. And just like in Rockwell, with your routines are called in the order in which you JSR to them. Same thing here. The function blocks and functions are called in the order in which you call them from an OB. Great question. But the group here has nothing to do with that. It is just strictly a way for you to organize your logic so that you can find stuff easier. So for instance, if it's your first day on the job and someone comes to you and says, hey, the mix tank sequence is stuck in step 6. Can you tell me why? Where do you think you would go find the logic for the mix tank sequence? Which of these folders? Sequences. Thank you. Yeah, not a trick question. Yeah, got to be in there, right? Unless the programmer is just completely insane. So much easier to find stuff if you use these group folders. All right, so I created a group folder named add-on instructions. Now, I typically would not have a group folder named add-on instructions in a Siemens PLC. That is a Rockwell term, right? Again, all my cool Siemens friends would laugh at me. Typically, what I name this folder is reusable blocks. These are blocks that I would reuse over and over again in my project, but not only in this PLC, in another PLC or in another project. All right, so let's open up this add-on instructions folder and see what we got in there. The lone scale EU function. This is the only function you'll find in this logic, and I didn't write it. I stole it from somebody else. It's just a way to scale an analog value.
Stole it from the European Union, I think.
So EU actually stands for engineering unit. But funny enough, our executive vice president created this function, and he is from Scotland. So ironically, true.
Yeah.
I guess, well, Scotland's not in the EU anymore, are they? Did they go out with Brexit?
Yeah, they did, I think. Yeah.
Yeah, I think Ireland is the only one left. Anyway, neither here nor there. Okay, but in Rockwell, the AOI that we looked at was the solenoid valve. And so there is a function block in here called AOI-SV. Again, I would not name my function block with an AOI prefix in a Siemens PLC, but we'll follow the same standard that we use in Rockwell. But let's open up this function block. Let's see what we got in here. So double click under add-on instructions. double click this AOI SV and let's compare it to the AOI that we just looked at in Rockwell. So double click under add-on instructions, AOI SV. Again, if it's logic that I have never seen before, I like to start by doing close all networks. Let's see how much logic I'm dealing with here. Not too bad, only 7 networks. Did I mention always, always, always put in a network title? Okay. So the first thing that we did in Rockwell when we defined our AOI was what parameters do we have? What inputs, what in-outs, and what outputs? If you expand the block interface up here, remember we looked at this in the OB, but here in a function block, we've got some different sections up here. So expand that down so you can see the whole block interface. And absolutely, we've got the same sections that we had in the AOI. We've got inputs, outputs, in-outs. I like to, when I'm defining my inputs, I like to prefix it with in for inputs and outs for outputs. This goes against the programming style guide. They said don't do this. But I find it much easier because when I'm down here writing ladder logic and I can't remember exactly what I named the tag, but I know it's an input, I can just start typing in and then it gives me a list of all my inputs and I can just select it from the list. So this is my naming convention. You don't have to follow it. But all my inputs, but they're the same as what we saw in Rockwell. There's the closed feedback of the valve. There's the open. There's the auto permissive, tell them when the valve it should open or not when in auto mode. And of course the interlock. And then the outputs tell the valve when to open and then send the fault out as well, just in case we want to turn on an alarm horn or a beacon. And then there's my HMI tag using the same UDT. So that gets me my auto request, my manual request, and all that from the operator interface. The next thing we did in Rockwell was we defined the local tags. Well, we don't have local tags, but we do have an area called static. Exactly the same as local in Rockwell. I can't write with the mouse, local. So any tag that you define here in the static area, its value is remembered in between scans of the PLC. The value is static. It stays there forever until you write another value into it. Same thing as local tags. So I've got a fault timer and I've got a one-shot array. They're not called one-shots in Rockwell, but are in Siemens, but I still call them that. And this is, by the way, the syntax for declaring an array in Siemens. Then I've got 2 additional areas that we really don't have in Rockwell. I've got this temp area. Those are temporary tags. Their value is not remembered in between scans of the PLC. They're temporary. So if you define a temp tag right here, you need to set it in your logic first before you use it. And then it does not remember in between scans of the PLC. So you come back around, you scan this again, your logic needs to set that temp tag and use it because you can't, it will not remember where it left off. And then the constant area is just a tag whose value never changes. In case you need something like that. All right, let's look at the logic. So this, very, very similar. Really, the only difference is we have some additional areas for temp and constant that we really don't have. Let's look at the logic. So we go back and we look at the Rockwell logic real quick. The very first rung was handle auto manual request from the HMI, and we had this rung right here. All right, let's look at network 1. Notice that the network title is the same as the run comment. Handle auto manual request from HMI. And let's expand network 1. Let's see what we got in there. So this looks a lot like what we just saw in Rockwell. To me, ladder logic is ladder logic is ladder logic. So if the HMI requests auto mode, reset manual actual, that's the same thing as an unlatch. Set auto actual, same thing as a latch. And then reset the auto request, handshaking with the HMI. Same for manual request. If we're not in manual, not in auto, latch up manual. And then we handle the manual open and the manual close. So that logic looks pretty similar to what we just saw in Rockwell. All right, let's take a look at network 2. Energize output. This looks almost exactly like what we saw in Rockwell. If we're in auto and the auto permissive input is true, or we're in manual and the HMI requests a manual open, the interlock is healthy, energize the output and let the HMI know. Again, ladder is ladder is ladder to me. Let's look at network 4. This one's a little more interesting. This is the fault timer, fault delay timer. Notice the TON instruction, same as the TON in Rockwell, timer on. So if we're asking the valve to energize and we don't have the open feedback, we're asking the valve to close, we don't have the closed feedback, or we have both the open and the closed feedback, not a good state for a valve to be in. We're going to start a timer and we're going to time for 5 seconds. In Rockwell, if I want a 5-second timer, what do I have to put in for the preset? So 5,000, right? Everything is in milliseconds. We got a little bit more flexibility here because of the time data type. So don't do this. You can just watch my screen. If I wanted this to be a 500 millisecond timer, I could just type in 500 ms, and that's a 500 millisecond timer.
That's the same thing they did in the 800s now.
Yeah.
Oh, do they? So they have embraced this time data type?
It looks identical. You actually give it a tag, but then you can go into the tag and it's the same thing.
It's this T pound. That's good.
You can also,
I mean-
it's kind of nice too, because you wanted 3.5 minutes, you would put 3M, 30S.
Absolutely.
Yeah, which is kind of nice.
Yeah, you could even do.
Yep.
That's a 10-day, 9-hour, 8-minute, 7-second, 10 millisecond timer. I use that one all the time. So that's sort of the strength of that time data type is that full use of the time data type, allowing you to type this sort of this combinational time in. So the PT obviously is the preset time, ET is the elapsed time, Q is the done bit. There is no timer timing bit, which I know we use that a lot in Rockwell, but you can get around that. If N is true and Q is false, then the timer's timing. So instead of a single tag, you got to use 2, but that's not too bad. Let's look at network 5. Pretty interesting here. So network 5, set position fault. So if the fault timer gets done, fault timer.q, this is how you address an individual bit inside of an integer. It's called bit slicing. Notice the syntax. Remember, alarm was an integer. So it's dot, percent, x, and then the bit number. And then this program alarm, this is a lot like the alarm D instruction inside of Rockwell, but it allows you to automatically generate an HMI alarm without creating any HMI alarm tags. Just happens automatically. All right, here's a question for you. I can get all this in one. Notice that all of these tags have a number sign in front of them. For the younger folks, a hashtag. What do you think that number sign is telling you?
They're trending. They've gone viral.
Yes, exactly. Next question. Any guesses on what that number sign is telling me?
Ins and outs, your preferences you passed into the call.
Yeah, more broad than that, they're defined up here in the block interface. Yeah, so they're either inputs or outputs or static or temp or constants. They're defined up here. Now, Rockwell, if you're developing or designing an AOI, it does not allow you to address anything in controller tags. In an AOI, all you can do is address parameters or local tags. So this would suggest that Siemens would actually allow you to address something that's defined out here. All right, so don't do this. Let's just try it. I'm going to show it to you. So like that that PLC tag that we created this morning for Lucky Level Switch 13, DI LSH 0013. Notice no number sign here, and also it's not complaining. This would absolutely run. This is considered poor programming practice. Why? All right, well, let's say we've developed this add-on instruction for this valve and we love it. We're quite proud of it. And we want all of our friends and neighbors, my friend Eddie that programs down the hall for me, I'm going to want him to use this function block in all of his projects. So I email him, I say, hey, Eddie, I created this great valve function block. I'm going to stick it up in a global library. Hopefully we'll get to that later today. You use it. So Eddie grabs it out of the global library, drags it into his project. What are the chances that Eddie has this tag in his PLC? Or more importantly, we know we're going to want to use this function block in every PLC we create from now on. Are we always going to have this tag in every PLC we ever create? Well, not a chance. So as soon as we do this, this function block is no longer portable. That's the key word we're looking at here is portability. As soon as I address something that's defined out here, I am no longer portable. So don't do that. If we really need that, what we would do is we would pass it in up here in an input parameter, not address it directly here. Delete that. We want to keep it portable. So even though Siemens says, I don't know why you want to do that, but okay, here you go ahead. For programming practice, we want to keep it everything local to the function block. All right, let's look at network 6. One more thing I want to show here. So ad nauseum, I have talked about the network title, how we're always going to use it. But you're limited to just one line here. If there is logic down here that's fairly complex, then you have something called a network title right here. And you can write a book, a novel, War and Peace right here in this area. I don't even know what the limit is. I've never run up against it. But what it allows you to do is explain the more complex logic that you have in here. So we can see here that the HMI status is going to have a 0 if it's moving, 1 if it's closed, 2 if it's open, and 3 if it's faulted. And if you look at the logic, it bears that out.
How do you get to that?
So it's always there. You may have to click this little black arrow to drop it down.
Oh, okay, yeah, you find it.
Got it?
Yeah. Yeah, Kai, see comment comes up, kind of grade, and you can type in the comments, got it.
I've, to Ron's point, I've literally written, I'll open like a notepad or a Word and type it in there and then just copy it and paste it into this.
Do you remember how big of a comment it was? How many characters? I'm always curious to see what there's got to be a limit. I just don't know what it is.
Yeah, I mean, the most I've done is, maybe a couple of paragraphs, but you know, maybe 1,000 characters, or I don't know, to be honest with you.
And that is stored in the PLC. So, you know, your tag names, your tag comments, your network titles, your network comments, all of that is stored in the PLC. So you got to figure they put a limit somewhere. I just don't know what it is. Sure, I could Google it, but I'm not that curious. All right, so once we've created the AOI, if we go back and we look at Rockwell, once we finish writing the logic, we then go and instantiate. We use the add-on instruction. And we said, well, we could put it right here in main routine. Yeah, we don't do that. Instead, we create an intermediate routine called mixed tank valves, where we'd find all of our valve logic. And we said, okay, if I'm thinking routine in Rockwell, I'm going to think function block in Siemens. So let's see if we can find a function block named mixed tank valves. All right, so where do you think you would find a function block named mixed tank valves?
Under valve.
Thank you. Yeah, not a trick question. Hopefully the developer was not insane and it's under valves. So did we have, oh, there it is. There's a function block named mixed tank valve. So this is a function block as a routine and not as an AOI. Let's open it up, see what we got. So double click mixed tank valves. So switch gears mentally here. This is not an AOI, this is a routine. This isn't a function block we're going to reuse over and over again. This is just an intermediate calling routine. Again, I like to start with my close all networks button. Let's see how many valves we're dealing with here. How many networks are we dealing with? Well, we know we've only got 2 valves in this. Valve 11, steam valve. Valve 12, the recirc valve. And yep, that's what we see here. All right, so if we take a look at network 1, this is a function block call. So it's got to have an instance data block. There's the instance data block. Where is this guy located? Oh, there he is right there. Okay, well, wait a minute. What if I have 50 valves? Does that mean I'm going to have 50 instance data blocks out here? Yeah, that's exactly what it means. So now all of a sudden, my project tree is all cluttered up with instance data blocks. Well, that's not good. I don't want that. Got to be a better way. I'm glad you asked. Let's go down to network 2. This is the call to valve 12, the recirc valve. All right, so it's the same function block call. There's the instance data block. What's that number sign in front of that instance data block telling me? The hashtag. What did it mean before?
Local.
It's local. Excellent. And notice where it put it. It put it in the static area of the block interface. Only a function block has a static area. Other than a global data block, we don't count that. So this, what this is called is a multi-instance data block. I hate the name, but that's what it's called. I've got it in the PowerPoint because when you leave today, you're not going to remember that term. But this is only possible when you call a function block from another function block, because only a function block has a static area. All right, so I've got this detailed in the PowerPoint. Get down to it. So if you do a single instance data block, then the data block gets created out here in the project tree, and we're going to get all cluttered up out there with instance data blocks. And I don't like that. The second way that we did it for valve 12 is called a multi-instance data block. It gets created in the static area of the calling function block. This is another reason, and it keeps our project tree uncluttered. This is another reason that I always lean towards function blocks and not functions. A function does not have a static area. So if you call a function block from a function, your only choice is to put it out here in the project tree. Let me show you what that looks like. So my very first project in TI Portal, I was self-taught. And so I sort of had it in my head, okay, if I'm thinking add-on instruction, I'm going to say function block. And if I'm thinking routine, I'm going to think function. So let me show you when I went down that road, what that caused to happen. Again, my first project, self-taught. If I could go back and do it again, I would. I developed this in like version 13, Service Pack 1, I think. And I recently converted to V18, and I was awfully tempted to change it then, but I thought, let's not run the risk of changing anything. Customer wasn't going to pay me to fix it, so, and it's not broken. I hate looking in the project tree, but let me show you what it looks like. Here we go. Pop over to project view. So I did do a great job, even back then, of really using these folders. You know, my logic is very well organized into the group folders. I like that. And then instead of a folder called add-on instructions, I named it custom objects. And so this particular project, they had like 19 belt conveyors. All right, so I created a add-on instruction, think function block, called belt conveyor. So I said, okay, AOI equals function block. But then I said, okay, I want to call this function block for all 19 belt conveyors. And I said that would typically go in a routine in Rockwell, so I'm going to make that a function. So I created a folder here called conveyors. I like that. Instead of a function block, I chose a function. As a result, if you look at the function and look up here at the block interface, notice there's no static area up here. Remember when we said a function block has local memory and a function does not have local memory? That's the static area. No static area. So then anytime I call that belt conveyor function block, my only choice was a single instance. And as a result, look at all these instance data blocks out here. One for every conveyor. And I did that everywhere. So if you look at like my wave feeders, there's 15 of those, 15 instance data blocks. Now, had I made this a function block instead, all these instance data blocks could have been tucked up into this static area. But because I went down this route, this is where I ended it up. That's why I don't use functions anymore. Everywhere, see, there's 15 silos. So I've got 15 instance data blocks out here.
A question.
Okay.
If you were online with the processor, where would you see live data for an instance?
So I can open up any one of these instance data blocks, and we're going to see this when we go online with the controller, but I can double click any of these instance data blocks, click my glasses, and then it adds a monitor column right here. All this shifts over, and you see the online value. And notice what I can see here in the instance data block. I can see the inputs, the in-outs, and the statics. I can't see temps and I can't see constants, but everything else I can see.
So if you're moving the data blocks into a local or a static Would you
Oh,
have
I
to
got
go
you.
into there to see the data?
Yeah, so there would be an instance data block inside of another instance data block.
Sure.
We'll see that. I'll show you in a second. Actually, I can show you now. All right, so because I went down the road here, instead of making this a function, I made it a function block. Now I've got that static area up here. So now I can do this. And so your question is okay, well, where can I monitor online the value inside this instance data block? If it's stored up here, where can I see it? Well, remember, I've got to call this guy from main OB1, which created this instance data block. And just look at this, I'll show it to you. So if I open up the calling instance data block, there is the instance data block inside another instance data block. So then again, all I'd have to do is just click my glasses on and we could see that. Make sense?
Yeah.
All right, great. So in general, does everybody sort of get the concept here? If I do a single instance data block, it works fine. You know, it's no more efficient to do it one way or the other, but I sure hate to go and open these folders up and just see a bunch of instance data blocks. So instead, you do a multi-instance data block, and this is only possible right here, can only be done if the function block is called inside another function block. All right, so this is what we're going to do. We know we have to write the logic for the level switch. So far in our quest to add level switch 13, all we've done is we've picked a spare IO point, we have created a UDT, and we've created a tag inside of that glob controller tags for level switch 13. What we have not done yet is actually created the add-on instruction, the function block for the level switch. And this is what we're going to do. So we're going to create the AOI. Now we could call this AOI directly from main, but just like you wouldn't do that in Rockwell from main routine, we're going to create an intermediate function block, think routine. So if we were going to name these, this would be a routine in Rockwell, and this would be an AOI. And this is, of course, main routine. So main routine is going to call a routine called level switches, and then level switches is going to call an AOI function block called level switch, or level switch 13. And later, next week, you know they're going to add 14 and eventually 15. But today, this is all we're going to do. So let's start by creating the level switch AOI function block. Now, we want this to be a reusable block. So we're going to have to keep it local, portable. All right. So let's put it in this add-on instructions folder. So right-click add-on instructions and do add new group. Add new block. So right-click add-on instructions and do add new block. Notice this is where you'd go to add an organization block, a function, or a data block. Let me just show you the different organization blocks while we're here. So the program cycle, that one's created for us, OB1. The startup OB, it only gets called when the processor first goes from stop to run. So remember, we saw the first scan bit. You could do startup logic there, or you can add a startup OB and do it there. Some of the other ones that I have used, the time of day OB. So if you want something to happen every day at noon, or a good example, the gas day for a natural gas facility usually starts at 9 a.m. So every day at 9 a.m., I reset all my totalizers for the day. I use a time of day organization block for that. All right, but we're adding an add-on instruction. We said, okay, if we're thinking AOI, we're going to think function block. So let's name it AOI, I hate using that term, level switch. So choose function block. Name it AOI level switch. We're going to use ladder as our programming language. Notice you could manually number your function blocks. I see no reason to do that. I don't care about the number. I care about the name. So I leave that in automatic. Make sure add new and open is selected. Just saves you a couple of clicks. And click OK. So function block, AOI level switch, ladder, automatic, add new and open, and click OK. So in Rockwell, when we're defining AOIs, first thing we need to do is define our parameters. Remember, that's done up here, block interface. So we need to define our inputs, our outputs, and our in-outs. All right, I'm going to type these in, and then I'll zoom in so you can see them. All right, so add this input, this output, and this in-out. Notice the data types. And of course, you're going to put in a comment. That goes without saying. Everybody's almost there.
We're good here.
All right. So if we know what static tags we need, we know what temporary tags, we could go ahead and fill those in, or we can just do it on the fly as we program. That's what we're going to do. So let's write a little bit of logic here. And I mean very little. This is very easy, a level switch that we're going to debounce. Assuming this is the first time you're seeing TI portal, this area right here, these are your favorite instructions. These are the ones that are there by default. You can drag and drop any instruction you want to here to your favorites area. So if you're using a timer all the time, drag and drop a timer down here. If it's not, if there's an instruction that's not up here, notice over here the task cards have automatically changed to our instruction palette. They're organized into several different areas, basic instructions, as the name suggests, bits and timers and counters and math and move and converts. And then we've got extended instructions, date and time of day, strings, some other ones that I've used, diagnostics, recipe and data logging. I've used technology instructions. So there are things called technology objects inside here, things to interface with VFDs or PID loops or high-speed counters. There are instructions in here to allow us to interface with those devices very easily. And then finally, communication, if you're doing PLC to PLC communications, Modbus TCP, Modbus RTU, think message instruction, if to use Rockwell terms. You can even get a Siemens PLC to talk to a Rockwell PLC. You know, there's a built-in, not a built-in, but there's a free function block you can download from the Siemens website if you need to do that. But pretty much everything we need right here. So obviously, you know what we're going to start with, a network title, always. So let's say debounce and alarm. It'll put you in a good network title, debounce and alarm. Let's just start with a normally open contact here, the simplest of instructions, and you can either drag and drop it down to the rung, or you can just click it and it'll put it to the right of the cursor, whichever you want to do. It's obviously not happy. Why? Because we've dropped instruction down. It don't have a tag assigned. See a red X. It's not happy. That's going to be our level switch input. Now remember, we want to keep this function block portable. So every tag we address needs to have this number sign in front of it. No fair coming out here. Don't want to do that.
You can drag and drop.
Yeah, you could. Instead of typing in level switch, you can drag and drop that down to here.
The way around the German keyboard.
I drag and drop all the time. I love it.
Yeah, there's drag and drop, particularly in Portal. They put a lot of thought into that. We'll see that in particular with the HMI development. Drag and drop saves a tremendous amount of time. So if the level switch is closed, and we are not normally closed, so let's drag one of these down. And remember, the normally closed is set from the HMI. So HMI dot normally closed. Then we want to start our debounce timer, but I want to come and do the debounce timer last because there's some discussion points around it. So for now, just grab the empty box, the mystery instruction, the placeholder, and just drag and drop it to right here. We'll come back later and fill in the timer instruction. If the timer gets done, then we want to energize both the HMI alarm and the function block output for alarm. So we're going to need two of these guys. Just the assignment instruction. OTE, using Rockwell terms. So make your rung look like this. Then, of course, we need to do the corollary here. If level switch is open and we are normally closed. So to do a start branch, all you got to do is grab this guy and drag and drop him to the beginning of the rung. Make your network look like this so far. If you missed that, this is the start branch. I just did a drag and drop to right here. To finish the branch, all you have to do is just grab the double arrowhead and start dragging. So you can see there are boxes that turn green, and we want to drop it right there. So if the level switch is closed and we're not normally closed, or the level switch is open and we are normally closed, we're going to start the debounce timer. When the debounce timer gets done, we're going to set the HMI alarm and the alarm coming out of the function block. So we need to tackle this debounce timer here. So the cool thing about the empty box or the mystery instruction, if you know the name of the instruction, all you got to do is type it in right here where the question marks are. And we saw earlier the TON instruction in Rockwell is the same as Siemens. So right here where the double question marks are, I'm just going to start typing TON. All right, now notice the TON instruction is dark blue. That means it is a function block. It just happens to be a function block that's built into the software. And we said anytime you use a function block, it's going to have an instance data block. Local memory. Got to be there. All right, here we go. Hit enter and enter. All right, so the software is saying, all right, you just dropped down a function block. I'm going to create you an instance data block. And it's asking us, what type do you want? Single instance or multi-instance? If I choose single instance, where does it get created?
Project tree.
Out here, exactly. And as soon as we do that, we are no longer portable. We are now referencing something out here as opposed to up here. So instead, if we choose multi-instance, we know it gets created here in the static area. And remember, a function block is the only program block that has a static area. So if you were trying to do this level switch in a function that had no static area, as soon as you tried to do a timer, your only choice would have been single instance. And now you've just created something that's not portable. That's another reason I don't choose functions. I always choose function blocks. You never know when you're going to need a timer. All right, so I'm going to choose multi-instance, and I'm going to name it stat since it's going to go in the static area. Debounce timer. So choose multi-instance, name it stat debounce timer, and click OK. Remember, the preset time is set from the HMI. HMI dot debounce time. And that's really all we need in this function block. So if the level switch is closed, we're not normally closed, or the level switch is open and we are normally closed, we're going to debounce for however long we set from the HMI. Timer gets done, tell the HMI we're in alarm, and then send the alarm out of the function block in case we wanted to turn on an alarm horn or something like that. All right, save your project. Don't want to lose anything. So far in our quest, we have created this guy. But we haven't called it. We need to call it for level switch 13. And sure, we could call it from main OB1, but just like you wouldn't call it from main routine, we don't want to do that. Instead, we want an intermediate routine. Think function block. Actually, I want to name it mixed tank level switches. All right, so we're going to create this guy now. So now right-click the top-level program blocks folder and do add new block. All right, so we're thinking routine. If I'm thinking routine, oh yeah, function block. So right-click, add new block. We're going to choose function block again. Mixed tank level switches. Name it mixed tank level switches. We're going to stay in ladder. Automatic. Add new and open. Saves us a couple of clicks. And click OK. So this is a function block as a routine. So here we're really not worried about portability. We're not going to reuse this function block in all of our other projects. I don't need to send this function block to my friend Eddie. I'm not worried about portability. This is a function block as a routine, not an AOI. But you know what we're always going to do? We're always going to put in a network title. LSH 13. All right, so we need to call our new AOI for level switch 13. So all we got to do is go grab it out of our out instructions folder and drag and drop it to network 1. Now it's a function block. It's got to have an instance data block. Won't work without it. All right, let's see what happens here. Make sure everybody's with me. All right, here we go. So we've got 3 different types of saying, all right, what kind of instance data block do you want me to give you? Now, I'm worried about portability here. And we haven't talked about the parameter instance. The parameter instance means you're going to pass in the data block in as an in-out parameter up here. That just seems more complicated than it's worth. So we're not going to consider that one. If I choose single instance, where is it going to put it? Out here? Which is fine. Remember, we're not worried about portability, but if we have 50 level switches, then we're going to end up with 50 data blocks out here. Think about that project I just showed you where I did that. I don't want that. I don't want to be cluttered out here with instance data blocks. So instead, we're going to choose multi-instance, which means it gets put up there in the static area. Keeps our project tree from getting cluttered. So I'm going to give you another out. Remember I said earlier today that we're always going to lean on the function block? You're also always going to lean on the multi-instance data block. If you're creating a reusable function block, choosing multi-instance keeps your function block portable. Or if you're calling another function block, it's going to keep your project tree uncluttered. The only time I choose a single instance data block is when that's the only choice that I have. If I'm given the choice, I'm always choosing multi-instance. Multi-instance, again, it's going to go in the static area, so we're going to name it stat LSH13. So multi-instance, stat LSH13, and OK. And it takes a stab here, by the way. I don't know if you noticed this. It takes a stab out of explaining what a multi-instance data block is. I don't know that it does a great job of explaining it. This allows you to concentrate the instance data in a single block and to get by with fewer instance data blocks in your program. Yeah, I guess that's what it's doing, but I like the terminology. It keeps your project tree from being cluttered up with data blocks, but maybe they didn't want to put cluttered up in their description. Notice where it put it. Not happy. Why is it not happy? Because of this. Well, let's start by filling in the digital input here. DI LSH13. And now we need the HMI tag. And the HMI tag, early this morning, we defined it in this global data block, glob controller tags. So again, I'm a big fan of drag and drop. If you just single click glob controller tags, just highlight it. So if you just single click it right here, down here in the details view, and you may have to expand it up or bring it up to be able to see it. But the details view lists all the tags that are defined in whatever you select up here. And there is our HMI tag for level switch 13. All you got to do is drag and drop it from there to there. You could also browse to it from here, but I really like the drag and drop.
Hey, Ron,
Yes.
could you really briefly show us, if you don't see that details view, how to get that?
So a couple of different things. If it doesn't show up at all, under view, there is a checkbox for details view. So make sure that is selected. So under view, make sure details view has a check box next to it. And then if it is showing like this down here, all you got to do is either click this arrow right here or just highlight right here and drag up. Oh, you can't drag up. If it's completely collapsed, you got to click the little arrow. There we go. So make sure you click this arrow if it's shown like that. And then you can drag it. All right, let me ask a question. Is this function block right here automatically called for us? Nope. Remember, the only thing that's automatically called for us are organization blocks, OBs. So where do we call this guy from? Well, in Rockwell, we would call it from main routine. So that's main OB1. So we need to call this.
Hey, sorry, Ron. We lost Wi-Fi for a couple of seconds here in the Maryland location.
Okay, where did y'all leave off? Did you get this done?
Yes. Yep. They're caught up with that. I think that was the last step we had right before we dropped off.
All right. So all I was saying is we know that this mixed tank level switches function block, it doesn't get called for us automatically, just like creating a routine in Rockwell doesn't get called automatically. Instead, we need to jump to it or call it from main. So main OB1. And main OB1 should be still up down here somewhere in your editor bar. Should be able to find it down there. If you can't, you can always find it right up underneath program blocks, main routine, or main OB1, not main routine. So we want to return to main OB1. Because the developer was very thorough in putting in network titles, we can see that network 5 is free. Of course, we're going to put in a good network title there, a network 5. Call level switches. Put that network title in for network 5 and OB1. Let's see if I can get all this in one. Yep, there we go. So I went to main OB1, came down to network 5, put in a good network title. To call the function block, just like any other function block, all we got to do is just drag and drop it. Let me collapse some of this so I can get everything on one screen here. So all we got to do is just drag and drop this guy to here. Now it's a function block, so it's got to have an instance data block. Got to be there. All right, here we go. Here's the $100,000 question. So we did a drag and drop to there. So I said, if you are given the choice, choose multi-instance. Why has the choice been taken away from me? Why no multi-instance here?
Guesses. So where are we following this block from? The main, right? What does main not have? Static.
There you go. because we are calling this function block from an organization block, an OB has no static area, so there's no room at the end for a multi-instance data block. So our only choice is a single instance. That's why I said the choice is taken away. If you have the choice, choose multi-instance, but eventually it will be taken away from you. Because it's going to be an instance data block out here, we're going to name it INST, mixed tank level switches. And click OK. So we've really completed this task that we've been given here. So main OB1 is calling mixed tank level switches. Mixed tank level switches is calling the AOI for level switch 13. So we're done. But I went on and on harping about these group folders. And now here we've got this guy and this guy hanging out right underneath program blocks. And if we start getting lazy and allowing that to happen, pretty soon, why even have these group folders? All right, so we're going to go back and we're going to add a group folder for all level switches. So right-click program blocks and do add new group. Add new group. That's what those folders are called. We're going to name it level switches. And then all you got to do is just drag and drop this into that folder and this into that folder. That doesn't change how it's called, anything like that. This is strictly organization inside your project tree. That's better. So this is what we have right now. And we know this because we just programmed it. But what if you were coming in cold and you didn't know the call structure of this project? All right, what calls what? How do I know? Siemens gives us it. There's really no way to do that in Rockwell. I think there's an offline tool that you can use. It's a third-party tool that one of our guys discovered that will go through and analyze like an L5X file and will map out all your JSRs and show you a call structure. But here we've got it built in. Underneath PLC mixed tank, if you scroll down a little ways, there's an area called program info right here. So double click program info. So under program info, you got several tabs here, but I want to go to the call structure tab. So at the very top level, you can see each of your OBs. Now there's a couple in here that we didn't really talk about. This MC servo, MC interpolator. That's motion control because I've dropped a VFD in there at one time. I've got some motion control OBs in there. Notice the lock symbol on them. These are not ones that we can do anything with. But main, we know that main is the first thing that gets called. And if we expand that, we can see that main calls the function block analog inputs, fixed speed motors, level switches, mixed tank valves, variable speed motors, and simulation. It also shows you the different global data blocks that are impacted by that call. So main calls mixed tank level switches, and mixed tank level switches then calls the AOI. So main calls, oops, main calls this, and then that calls that. This is always up to date. You can always go in there and take a look and see what calls what calls what. You can also look at the assignment list tab, and this will show you what IO has been assigned. So your I's and your Q's, see what all is being used. Save your project. Don't want to lose anything. All right, so we've really completed our task as far as the PLC is concerned. But before we can download to the simulator, we really need to compile everything and make sure we don't have any compile errors. And the compile is context sensitive. So the compile button is this button right here on the toolbar. But it's only going to compile what you have selected out here in the project tree. So for instance, if I only had the default tag table. So if I went down here and only selected the default tag table and hit compile, it's only going to compile the default tag table. Well, I've got all kind of code up here that needs compiling too. So when it's the very first compile, what I'll typically do is I'll select the whole PLC, very top level, and hit the compile button. And this is going to compile hardware and software changes since the last compile. This is a delta compile. We haven't made any hardware changes, so it's not going to compile any hardware, but select your PLC where I'm showing there in the project tree, and then hit that compile button. And let's make sure we don't have any programming errors. So the inspector window down below is going to show you your compile results. And so mine finished with 0 errors and 0 warnings. So Juliet and Todd, if y'all are there, can we make sure there are no compile errors?
Yes, sir.
Got a warning.
Yeah, you're good. So, yeah, warnings won't stop you in a compile. Ron, a couple of them are getting the, no password on the PLC display.
Ah, okay.
That kind of generic error, but that's a warning. That doesn't stop you from downloading, executing code or anything like that.
Yeah, and typically we don't want to leave blank passwords. You know, imagine someone being able to go up to your display in the field and put the PLC in program mode. That would be like leaving the key switch on the front of the PLC on a control logics. So it's just saying, you know what, you really should put a password there. Let me show you what an error would look like. I'm going to actually create an error just so you can see it. How about there? So notice how errors are displayed.
Lost it a little bit.
So you sort of have this tree view. Obviously a red X is an error. All right, so I've got a red X in the PLC. I keep coming down. It's not in the hardware. Oh, it's in program blocks. It's in the folder add-on instructions. It is the add-on instruction level switch. It's in network 2, and it says the network does not comply with the rules for ladder. But then it also gives me this go-to column with a jump green arrow. So I can click that and it'll take me right to where the error is. Yeah, this isn't legal. Got an empty rung and then a branch and nothing on it. It doesn't like that. So I can delete that, compile it again, and now I'm good. Juliet, are y'all all good on your side? I think you're muted over there.
Yes, we're all good on our end.
All right, great, sweet.
Thanks.
Okay. So again, save your project. We don't want to lose anything. So we are ready to download to the PLC. We want to test out the code before we jump into HMI development. So let's talk just a little bit about communications before we do that. Fairly self-explanatory, this term to remember. AOI equals function block. I almost said Facebook. AOI equals function block. Inputs are inputs, outputs are outputs, in-outs are in-outs, local is static. Really don't have a temporary or constant area in Rockwell. I think there are some check boxes you can select on some tags. So let me ask the question here. If you had a brand new Rockwell PLC, brand new right out of the box, got that new PLC smell, you get to break the factory seal. How do you get communications established to it? Let's say it's an L81E, so there's an Ethernet port on board the processor.
Easiest way?
Sure.
Yes. I'm trying, actually, I can't remember if it is on the control logics, but one of the first things I always do is just reach for the serial cable.
Okay, so on the L81, there is no serial port. It only has an Ethernet port on board.
Yep.
It doesn't even have a USB port. Anybody ever taken an L8 right out of the box and got communications established? All right, so we slap it in the chassis, we power it up, we connect our laptop. What software has to be configured to allow us to get communication between the laptop and the PLC? Links, right? Either factory talk links or RS links. Hopefully you've gone to factory talk links. RS links has got to go away. So then what do? You got communications established. What firmware is in the processor when you get it from the factory?
Wrong one.
Yeah.
Wrong one.
Yeah, almost nothing, right? It's like 1.076, something like that. It's just enough firmware for the communication ports to work, and that's it. So the first thing we've got to do is we've got to flash the firmware, because Rockwell doesn't know what version software you're using, so they're not going to ship the PLC with firmware in it. And what do you got to use to flash the firmware?
Control flash.
Yep, either Control Flash or Control Flash Plus. You need to download the firmware from the Rockwell website. Once you've got the firmware flash, and hopefully you don't brick the PLC. You don't lose power, or kick your Ethernet cable or anything crazy like that. So I actually bricked my first PLC, and it was a Micrologix 800, as a matter of fact. Right in the middle of flashing the firmware, it bombed, and I never could get communications reestablished. I had to send it back and get a new one. All right, so once the firmware is flashed, communications are established, we can download our project. So it's a little bit different with Siemens. With Siemens, you don't have a standalone software package like Lynx. It's built into the software. The PLC is going to ship with the latest firmware in it. Because remember, we're not mirrored. We don't have to mirror our software version to firmware version. So as long as you have the latest software, you can program all versions of firmware.
Question for that.
Okay.
What about the other way? If I only have, say, version 17 and I get a 19, what are my options?
All right. So, all right, two sort of questions there. So you've got version 17 and you get a version 19 project. Is that what you're saying?
No, if I have version 17 software, because I've been using older stuff and now I buy a new processor and you ship it to me with 19, which is the newest version, what are my options?
Well, remember, it wouldn't have version 19 firmware in it. It would have like version 3.1 or something like that.
Okay, yeah, I get what you're saying.
Okay. So if that's the case, so there are, it really depends on, okay, let me think about it for a second. Is there a project in that PLC, or it's a brand new out of the box and it just has the latest firmware?
I'd say it's new.
Okay. All right. Awesome. All right. So if it's brand new out of the box and it's got version 3.1 and you're way back at, let's say, version 16, and version 16 doesn't know anything about that version 3.1 firmware. So there is a chance that you could run, and this is a bad example, but there are HSP or hardware support packages that you can download from the Siemens website. It's like downloading an EDS file from Rockwell to make the software know what it is. But if the hardware is so new that the version 16 doesn't know it, then at that point, what you really need to do is you'll have to flash the firmware down to 2.8 or whatever it is that the version 16 would know about. And the process there is a lot like what you would do inside of Rockwell, except you don't have to have a standalone software package like Control Flash. Let me show you real quick. So I've actually got a PLC powered up here in my office.
And does that open a bunch of doors like doing that to Now and Bradley does? You downgrade an Allen Bradley, you can only downgrade them so far, and then you have hardware issues to worry about.
So yeah, you won't be able. So with firmware in Siemens, you won't be able to download firmware for a part number if it's not compatible. So you actually download firmware from the Siemens website based on the part number of your PLC.
Okay.
And so you can see the part number like of our PLC. Go back to our catalog information. So I would need that part number. I would go to the Siemens website. I would say I need firmware for this PLC. If there wasn't a version 3. Let's say, let's skip ahead, 4.0 firmware, then I wouldn't be able to download it. It wouldn't exist. And that's another way that Siemens keeps up with it, is because of those last 5 digits, 6 digits of the part number.
Of course,
that's another way that it controls
upgrade
it.
your software, right?
Absolutely. Yes. But to answer your question, the way that you would flash a firmware, I'll show you here. So I've actually got a PLC powered up. At least I think I do. Yep, there it is. So even without a project open, I can go online with the PLC. And go to online and diagnostics. Go to functions, firmware update. So this, you don't have Control Flash or Control Flash Plus, all built into TI Portal. You can do this without having a project loaded. Again, you'll download the firmware from the Siemens website and do it right from here. And you can even do it from the built-in web server, but assuming this is a PLC right out of the box, the web server wouldn't be enabled. So this would be the way you would do it.
Thank you.
Yep, great question. All right, so we don't have a standalone software package like RS Links or Factory Talk Links. It's all integrated into Portal. We already said that every PLC, both the 1200, the 1500, all of them have at least one Ethernet port on board. So we know we're going to be talking Ethernet. And where you would find that is on the toolbar. There's a button for accessible devices. So everybody click that button, accessible devices. Now you don't have any hardware in front of you, so you're not going to find anything, but let's at least go through the process here so you can see what it looks like.
So if you weren't plugged into something, when you hit this, it would show you that?
Yes.
Yeah.
And so I've actually plugged into some stuff, so we'll see what it looks like on mine. So the first thing it's asking us is, what type of interface do you want me to use? Meaning, what protocol? Now, we said every PLC has an Ethernet port on it. Most PCs have some type of Ethernet on it. So we know we're going to talk Ethernet. So if we hit the drop-down box, we're going to select this Profinet / industrial Ethernet. Now yours may be grayed out because you're not connected to anything. If that's the case, if you're grayed out, you can just look at my screen. But the next thing it's asking us is, which NIC card in your PC do you want me to use? Now these field PGs that are in front of you, these Siemens field PGs actually have 3 NICs on them, 2 copper and 1 wireless. Now they don't have anything plugged in, so they might be grayed out. So you might want to just look at mine. But I'm going to select my L network adapter. And then I'm going to click Start Search. So if you're able to select the PG-PC interface, select it, and then click Start Search. This is going to go out and it's going to browse the entire network for any Profinet capable devices. And it's going to show them in this list right here. All right, now again, you're not going to find anything, but you can look at my screen and you can see I have found several devices here. I have found some ET200 SPIO. I have found a 7-inch unified comfort panel. I have found a KP8 keypad panel, and I have found a 1515 PLC. All right, well, how do I know let's say there was multiple PLCs in this list. How do I know I'm actually talking to the PLC I need to talk to? Well, that's where this flash LED comes in. All right, so I'm going to turn my camera back on here. I'm going to stop sharing. All right, so you can see my camera. I'm just going to bump it up a little bit here. So in my list here, I'm going to select flash LED for that PLC. And you can see the LED start to flash. So that gives me visual confirmation that the PLC I'm about to download to is the correct PLC. You really don't want to download to the wrong PLC. You think you're downloading to the one sitting on your desk, and you actually download to the one on the line, and you're forcing IO and doing all kind of crazy stuff. Production has no sense of humor when it comes to that. All right, let me turn my camera back off. But you can flash those LEDs. You can flash the HMI screen, the VFD. Everything supports this flash LED. But what this does is this gives us confirmation that we've got good communication between our laptop and whatever device it is we're trying to download to. All right, so let's cancel out of this. Well, because you don't have any hardware, we really need to get the simulator going. So let's talk just a little bit about simulation. Anybody in here used Studio 5000 Emulate?
Yeah.
All right, what are your thoughts on Emulate?
I actually found it pretty useful. You pay extra for it,
Yeah.
or that professional package.
Yeah, it's useful, but it's problematic. You know, one of the problems that I have with it is I have to change my project. So if I've programmed my project for an L81E, well, that's not a good example, an L75. Well, as soon as I try to download to the emulator, it's going to say, oh, you've set up your project for L75. I'm going to have to change that processor type to the emulator. So you're already changing this project so that you can run it on the emulator. And then there's just a lot of manual configuration you have to do with Emulate. The other problem I have is it only emulates an L7 control logics. It doesn't do the L8. It doesn't do compact logics. It doesn't do safety. And yeah, you're right. Unless you've got professional, it's list price $1,600. Well, PLC Sim is free, comes with step 7. You don't have to change your processor type. It launches automatically. It simulates every 1500, every 1200, the ET200SP CPUs. It simulates all your I/O. It has some built-in, very simple sequences that you can program, I/O sequences. You can cause diagnostic faults to happen, so you can test your code. What happens when it loses communication to a rack? And again, it's free. It's just so easy to use. If you want to simulate an L8 processor, you have to have something called FactoryTalk Logic's Echo. Anybody used Echo? Dang, I was hoping somebody had used Echo because I've not used it either. The reason I haven't used it is this. There is no perpetual license. There is only a yearly subscription, and it's $2,000 a year. And I'm just we're not gonna pay that. So what we have is we've just got a pool of Control Logic's processors that we test on, and hopefully nobody's using it when you're wanting to test. So Echo is a little bit better than Emulate. The controller type doesn't have to change. It does all the L8 family, including guard logics. You still have to do some manual configuration. It doesn't simulate I/O, and there's still no emulator for our compact logics. Again, same bullet points for PLC Sim. Now there is a licensed version of PLC Sim called PLC Sim Advanced, and it's got some additional capabilities over the free version. For instance, you can run PLC Sim Advanced on another PC, or you could speed up or slow down the processor if you're wanting to do some slow testing, or you want to speed up so you don't have to wait as long. You can have up to 16 instances running simultaneously, and those instances can talk to each other. There's a table in the PowerPoint that shows you the free version versus the licensed version. I've highlighted the important areas where they differ. I'm not going to go through all that. You can look at that later. But we're going to be using the free version today. If you've never seen Emulate, this is what it looks like. Again, notice it only does a 5570 controller. And once you get online, none of the I/O is responding. Emulate just doesn't do that. I don't have any screenshots of Echo just because it's too expensive. I don't have it. All right, so to start the simulator in Siemens, it's very easy. Now again, save your project if you haven't done so. But to start simulation, all we have to know, we've already compiled, so we know we've got no errors in our compile. All we've got to do is select the PLC we want to simulate. So just select it there in the project tree. and click the Start Simulation button. So select the PLC and click Start Simulate. You get this warning message: starting simulation will disable all other online interfaces. Again, this is an important point. If you are running the simulator, you will not be able to get to the outside world. That's what this warning is. It's shutting down your NIC cards as far as Profinet is concerned. Because again, it would be bad if you thought you were online with the simulator and you're doing all this crazy stuff, forcing IO and all that, but you're actually online with a PLC in the plant. The software is saying, nope, not going to let you do that. You're running the simulator, you're stuck inside your PC. The software is protecting me from me. All right, so we'll click OK. PLC sim gets launched, and you probably won't see this workspace right here. That's fine. Once your PLC sim launches, we want to go to the Instances tab. We're not going to worry about creating a workspace. We just want to jump over to the Instances tab.
All right, I got a question for you.
All right.
I checked earlier when we were on break, these things are running i7s with 64 gig of RAM, and when we brought up the simulator, everyone in this room jumped into a performance mode. So talk to me about that.
Yeah, I was going to say, did you hear your fan rev up? So absolutely. I mean, you're running a PLC on your PC, and it's an exact duplicate of the actual PLC. So yeah, it is a load on your PC, absolutely, without a doubt. So that's one of the reasons I like PLC Sim Advanced, because I can actually run it on a different PC. Because I mean, TI Portal itself takes up a lot of resources, and then you're going to launch PLC Sim on top of that. That's more resources. And so absolutely, if you're gonna, I wouldn't recommend running, and I wouldn't run this on anything less than 16 gig. You know, Portal alone is going to eat up a lot of that. So
Thank you for the
absolutely.
justification, get my laptop upgraded. I appreciate it.
Yeah, I'm going to approve that. Go ahead and get that done. All right, so if you click on that Instances tab, notice that it has launched the simulator. It's in stop mode, of course, because we haven't downloaded to it yet. It's in stop. It says unconfigured because, again, it doesn't know what kind of PLC it wants to, that you want to simulate. So for now, let's just minimize PLC Sim. Let's get it out of our way. It'll continue to run in the background. So just minimize it. And now notice that my TI Portal has popped up this warning message. Hey, this thing might not be a trustworthy device. Sadly, in this day and age, we have to worry about cybersecurity and all that stuff. And so by default, since version 17 Service Pack 1, I think, security is built in by default. And so what it's saying is, okay, you're about to connect to a device that has a self-signed certificate, and we don't know anything about it. Are you sure you want to connect to this thing? Now, you're going to get this same message if you're talking to the simulator or if you're talking to a real PLC. Unless you actually go through the motions of getting signed certificates from a COA, you're going to get this. And again, sadly, this is the world that we live in now. All right, well, we trust our simulator, so go ahead and click the connect button.
I don't have it.
Say again?
We don't have that.
You didn't get the,
Oh, you didn't get that warning at all.
oh, I think you will get it.
When you get load.
I'm probably, yeah, oh, I see. Yeah, because I'd already connected to mine earlier today.
Yeah,
Yours may
yep.
look a little different than mine.
Yeah, we gotta go through the attempt to load it first, I think.
All right, so wait. I know what you have. You've got something like this. You've got the extended download to device. All right, so you've got this.
Yep.
All right. So notice it automatically went to Profinet. Notice that the NIC is grayed out. That was that warning message we got. Hey, you're running the simulator. I'm not going to let you get to the outside world. You're stuck with PLC Sim. The next thing it's asking us is which port on the PLC are you connected to? Remember, this is the X1 port. This is the X2 port. This is the X3 port. Well, we're not connected to any port. Everything's simulated. Everything's virtual. So it really doesn't matter what we select here. I'm going to leave mine at X1. That's fine. And it automatically refreshed the device list, and it should be showing your simulator right there. Unfortunately, the flash LED does not flash the simulator LEDs. There are some limitations to PLC Sim, but you can select it there in the list. It's probably already selected, and click load. And this is the exact workflow that you're going to do, whether it's the simulator or an actual PLC. As far as the software is concerned, it's talking to a real PLC. It's one of the nice things about PLC Sim. This is the same whether it's a real PLC or the simulator. All right, so we click load. There we get the not trustworthy device. Yes, we trust it. We're going to click connect. It tells us what it's about to do. Notice there's no warning that's going to stop the PLC. That's because the PLC is already stopped. We just powered it up. There's no project in it. So let's click the load button.
Intermediate window.
Oh, go ahead. Okay. Yeah.
We got a couple of, Ron, a couple of students got the pop-up for, do you want to save these default PGPC settings?
If you get that, say yes.
Yeah.
That's like in Studio 5000 where it saves the path with the project. So you don't have to do that every time. Yep. Once it's done downloading, make sure you put it in Start module. You're just putting it in run mode. And click finish. If you go back and look at PLC Sim, you can see that it is starting up. Takes it just a few seconds there to get all your I/O and all that stuff lined up and start simulating. And then we'll see it go to run mode. And the speed at which it does this is directly correlated to how much memory and your processor in your PC. So yet another reason to upgrade that laptop. And I really love these Siemens Field PGs.
Yeah, I'm sure the
They're-
price could fix it.
they are almost indestructible, almost. But they've also got serial ports on board. It's just so hard to find a serial port anymore. All right, so I've gone to run mode. I'm good. I'm going to minimize PLC Sim again. We are ready to go. See, we came back from lunch. We've been, all right, yeah, we need to take a break here in just a second. One more thing, and then we'll take our last break of the day. To go online with the PLC, Pretty simple. Select which PLC in the project tree you want to go online with, and click the Go Online button. Orange equals online. So do that. Select the PLC and click Go Online. If you see orange on the project tree header, that means you're online with at least one device in your project. And then you just follow it down until you see what you're online with, PLC mix tank. And then we've got all these green check boxes and green circles. What is all that telling me? So the green check box tells you that all the hardware is healthy. Okay, PLC sim is doing its job. So everything that we've configured, all the IO, everything's good. And then the green light indicates that the offline and online versions of each object match. It's constantly comparing what's running in the PLC to what you have in your offline project to make sure there are no differences. If there are any differences, you start to see some different symbols down here. Well, first of all, if you've got a hardware error, you're going to see a red exclamation point, and we're going to cause that a little bit later today. An orange exclamation point here tells us that we do have some differences between our online and offline code. And then we can just follow it down until we see these different Pepsi symbols. So this guy right here tells us that object exists in both the online and offline projects, but they're not the same. Some modification has been made. This one tells us the object exists online only and not offline. The orange online is solid, hollow blue, so the object is not offline. And that can happen if someone else is online with their laptop, they download a new function block, you don't have it in your offline project, you have to do an upload to get it into your project. And then the opposite of that here, the object exists offline only. You haven't downloaded it yet. We're going to see that one today. And then green, the online and offline versions match. That's where we are because we just downloaded. This is what it would look like if you had some differences. If you had a hardware error, you could see the red exclamation point. If you got some software differences, you could see the orange. So this is telling me, hey, main, it exists in both your offline and online project, but they're not the same. And we can do an offline to online compare to see what the differences are. We'll see that a little bit later. Okay, let's take a 10-minute break. And when we come back, we're going to do all that fun online stuff. We're going to monitor tags. We're going to add tags. We're going to monitor logic, searches, and cross references and make online edits. All right, so I'm going to start a 10-minute timer here. And I'll see you guys in 10 minutes.
Sounds great.
right, let's get started. We'll finish up today. So we've got what, a little over an hour left before I want to open it up for Q&A. So we should have plenty of time to get done what we want to get done here. All right, so we've successfully compiled everything. We've downloaded. We've got the simulator running. We're up and running. Everything we're going to do from here on out, we're going to attempt to do it online. And I'm putting online in air quotes because with Siemens, we really don't do anything online. Everything's done offline and we download. And as Rockwell programmers, we hear, oh, download, that means stopping the PLC. No, with Siemens, the only time you stop the PLC during a download is when there's been a hardware change. We can do software changes all day long. That's one of my biggest gripes in Rockwell with the add-on instruction is, I can't change a normally open contact to a normally closed contact online with the PLC in an AOI. That's got to be done offline, which means download, which means stop. I can change function blocks all day long, download to the PLC, and it not stop the processor. And we're going to see that. All right, so the first thing that when we're online with the PLC, one of the first things that we do, one of the most common things that we do, is we want to monitor just tag values. And we can monitor tag values in a global data block. We can do them in the default tag table under PLC tags. But let's jump right to the global data block. So down in the editor bar, you should have glob controller tags still open. Let's bring it back to the front. Bring glob controller tags back to the front. Here's another big difference from what you're used to in Rockwell. In Rockwell, if you're online with the PLC, then you're online with controller tags. Well, we are online with the PLC, but notice that the header up here is dark blue. We are not monitoring this global data block. So to do that, we've got to turn our glasses on. And I think, by the way, the reason they do this is sort of a holdover from the old days with Step 7 Classic, where PC performance back then isn't what it is today. PLC performance back then, not what it is today. And so communication networks aren't as high performing then as they are today. And so you could actually bog down your PC or the PLC if you had too many windows open trying to look at tags all at the same time. So I think that's what this is. So you have to explicitly go and turn your glasses on here to start monitoring tag values. All right, so let's turn our glasses on here. And let's start by monitoring tag HMI SV11. That's our steam valve interface to the HMI. We can see values here. The valve is in manual mode. Its status is a 1, which is closed. So from here, we could actually do a manual open request if you double click right here. So if you double click the manual open, it'll ask, do you want to toggle it to true? We can say yes. Manual open, say yes. You can see the output state goes to true. Now the manual open request is immediately going to go to false because remember, that's part of the code. It unlatches it. But we can see that the output goes to true and the status eventually gets to 2, which tells us that it is open. And let's go ahead and close it. So double click the manual close request right here. So we'll toggle the manual close request to true. Toggle value, yes. And we can see the status goes to 0 and then to a 1 to tell us it's closed. So very easy to manipulate tags here. We can even manipulate non-Boolean tags. If we go down and expand, how about HMI sequence mix tank? So expand this tag. We can see that the step number is in 1 right now. We can see that the current step time is incrementing. Mine's not because I'm zoomed in, but yours will be. But let's take the sequence to step 6. So double click this step number right here, number 1, and then just type in the number 6. We're going to take the sequence to step 6. Double click. Hit a double click right there. Type in a number 6 for the modify value. Click OK. As long as your code doesn't overwrite it, it's static. The value stays at 6. And we can see it actually goes to waiting for the temperature to be above 90 degrees C. All right, what if we wanted to add a tag to this global data block? So I want to talk about some of these other buttons up here at the top. If we want to add a tag to this global data block, first of all, if your LSH 13 is expanded, let's collapse it. I don't want it to be expanded, or you can just click this button. Actually, you have to hit it twice. But what I want to do is I want to add a tag to this global data block. So I'm going to select this LSH 13 tag, the very bottom tag. I'm going to right click it, and I'm going to do an add row. So select this HMI LSH 13, right click it, and click add row. Now remember, the sequence is in step 6 right now. Just keep that in mind. They're making product. All right, we're going to add a row here. So right click, add row, and we're just going to name it my new tag 1, and it'll be a double integer. My new tag 1, double integer. Now we attempted to add this tag online, but notice what happened. As soon as we hit enter, dark blue header, we actually went offline. We don't really make changes online to a Siemens PLC. And now we've got all these orange exclamation points. And if we expand it a little bit, we can see all kind of Pepsi symbols. So we've got differences, changes between our offline code and our online code. Well, we know what the change is. We just made the change. We added this tag. And we added it to this glob controller tag. Now we've got other exclamation points in here because it's also saying all of the program blocks that reference controller tags are also suspect. So that's why you see some additional. So we want to download this change. That's how we go from our offline to our online. So again, it's context sensitive based on what you have selected over here in the project tree. So I want to download this global data block controller tag. So I'm going to select it. Just single click it. And I'm going to hit the download button. Now this is not a hardware change. It's not going to stop the processor. Let's see what happens though. So select the global data block, glob controller tags, and hit download. Anywhere you see pink is a question that you have to answer before it's going to allow you to move on. And it's an important message. So what it's saying here is the data blocks will be reinitialized with their start values. Doesn't sound good. If I expand this black triangle right here, it'll give me some additional information underneath there. Due to changes in the data block, all data values, including retentive data, will be initialized with their defined start values during loading. Set the CPU to stop before loading. Now remember, we are in step 6 of the sequence. And if you remember, the step number default value is a 1. Is this about to set the sequence, take it from step 6, where they're making product, to step 1, which is idle? That's what this is suggesting. Let's find out. So where it says no action, let's change it to, yeah, we know what we're doing. Reinitialize. And click load.
Why does it say, Ron, set the CPU to stop?
Because what it's saying there is what you are about to do is fairly catastrophic, because you're going to set every tag in that global data block to its default value. And it's saying, look, that is a pretty major deal. You might want to just stop the CPU and do it. It's letting you know that even though it's not going to stop the PLC, you're doing some very, it's risky behavior, let's say. Let's see what happens. Let's click load. So did it do what it said it was going to do? If I expand the sequence mix tank again, oh yeah. Step number went back to 1. You just reset the sequence. You aborted the sequence. You ruined whatever was in the tank. Your phone is ringing.
This is when you start sweating.
Yep, this is where you take the phone off the hook. So obviously this is catastrophic, and adding tags to a global data block is something that we do all the time. You know, we always add tags. So how do we get around this? Well, before I show you, let's take it back to step 6. So again, next to step number, double click the 1 there. Maybe you can save the batch, I don't know. But double click the number 1 there, type in 6, and let's click OK. Let's get it back into step 6. Yeah, then when your phone rings, I still show it in step 6.
I didn't touch anything.
I'm not even here. All right. So how do we get around this? How do we add a tag to a global data block without that? Because that is not good. That is where this first button comes in, the keep actual values button. So let's start by clicking that button. So click this keep actual values button. Now this is important. This is something that you're going to do all the time. The rest of these buttons I don't really use, but this one I want to make sure we cover. So let's click the keep actual values button. We get a warning message or a notification saying, do you want to enable the block function load without reinitialization? You can download changes to the block and run without having to reinitialize the program. That sounds pretty promising. The number of possible changes is limited. All right, let's click OK. Notice we get the Pepsi symbol out here. Need to download. So select this glob controller tags again. Click download. Notice you won't see any pink warning messages. It's not going to stop the processor. It's not going to reinitialize everything. All we're doing is we're just saying, set this data block to keep actual values. All right, so if we hit the download button, yep, we're clean. No pink messages. Click load. Sequence is still in step 6. We haven't caused any major problems here, but notice what it did. The name and the data type columns are now grayed out. We can't make any changes to the name or data types of any of the tags that currently exist in the global data block. And Rockwell actually does this too, sort of behind the scenes. Now, in Rockwell, we can change the name of a tag, but online with the PLC, we cannot change its data type. And so that's all we're really doing here is we're just locking down those existing tags. And I think this is one of the reasons, remember early today, I told you about that rule of thumb where Siemens uses half the memory of Rockwell. I think this is why. Because I think what Rockwell does behind the scenes is it allocates a bunch of memory so that you can add tags without affecting anything that's already existing. And with Siemens, they're saying, I'm not going to reserve that extra memory unless you ask me to. And we ask them to reserve that memory by clicking that button. That's a complete theory on my part, but it seems plausible. All right, let's see if we can add a new tag now without setting that sequence back to step 1. So down here, let's go back and let's add, you guessed it, my new tag 2. Oh, I'll show you something cool here, by the way. One of the things that you can do if you select this tag, and you got some Excel functionality where if you grab that and just drag and drop it, it'll automatically create my new tag 2. I think that's what it calls it. I say that. Oh, you can't do it when you're online. Never mind. We're just going to type in my new tag 2. Double integer. Again, we get the Pepsi symbols. Let's download this data block. And now let's see if we get that same pink warning about reinitialization. Hopefully we don't. So I'm going to select the data block here in the project tree and click download. Hopefully you don't see that pink warning message. Let's see. Nope. Oh, I'm scared to hit load though. They really chewed me out last time. Let's give it a shot here. Let's click load, make sure it rides through. Ah, thank goodness, stayed in step 6. All right, so if you leave with nothing else today, before you add a tag to a global data block and your system is running, the process is running, the machine is running, make sure you click this button. That's what allows you to add tags to a running process. And remember when it said that the number of changes was limited? Let me show you that. Just look at my screen here. If I go to the properties of that global data block, there's an area called download without initialization here. And by default, it reserves 100 bytes. Now you can change that. So if it's a global data block that you think you're going to be adding tags to a lot, you may want to bump that up. Notice I only have 96 bytes available. That's because I just added a double integer that took up 4 bytes. I'm down to 96 bytes now. And the only way to free that memory back up is to deselect this button, but that's going to reinitialize values. So you're going to want to do that on a down day, machine's down week, whatever it is. This is a good time to go and free up that memory. This is another reason why I don't just create one huge global data block and stick all my tags in there. I do a bunch of global data blocks. In general, what I do is for every group folder I have, I've got a global data block.
Sounds that sounds Rockwell-esque.
Yeah, I know. That's probably why I do it. It's because I spent 20 years programming Rockwell. It's almost like creating program tags, you know, for each of your folders.
So I have a question. When
Right.
we had the pink that we had to select, we couldn't select not to initialize and move forward from there. In other
Nope.
words, just you have to.
If you don't select that, the OK button is grayed out. Your only choice is to cancel.
Didn't notice. Thank you.
Yep. Any questions on that workflow? By the way, if you're in doubt, you know, if you've got a running PLC and you think, man, I don't know what this is going to do, launch it in PLC Sim. You know, the behavior in PLC Sim is exactly what it's going to happen inside the PLC. So test it. See what's going to happen before you do it to a live PLC. PLC Sim is free. It's always there. Just hit start simulation. You can see what happens. That's what I do.
And if it breaks your laptop, probably don't value it.
Exactly. Good rule of thumb. If your laptop blue screens, don't do it. The next button over. Any more questions on this keep actual values button? That's an important one. All right, snapshot. Everybody click this button. The camera with the upload green arrow. Click that button. So what it does is it creates this snapshot column and it grabs all of the online values in the PLC and stores it offline in this snapshot column.
That's grayed out.
If it is grayed out, then you need to click a tag down here, and then it should be where you can click it. It's context sensitive based on what you have selected. So like if I select over here, notice it's grayed out. You got to actually have the data block itself highlighted before you can do it. All right, so that just stores an offline copy of what's currently in the PLC. And then the button next to it, if you were to click that, it takes that snapshot value and writes it down to each tag in the PLC. So it will set every tag to the snapshot value. Seems awfully catastrophic. I have used these buttons one time. When I upgraded that facility from version 13 to version 18, I didn't want to lose all those runtime hours on those motors. So before I did anything, I grabbed a snapshot, and I can actually do it instead of going to each global data block and hitting this button. You can actually come all the way up to the program blocks and do it. So if you do it from here, it grabs a snapshot of every data block, what's currently in the PLC. So that's where I started before I did my conversion. I right-clicked, I did a snapshot, grabbed every value, converted the project to version 17, updated the firmware, did a download, and then turned right around and did a load snapshot as actual values. That way I didn't lose a single thing. It's the only time I've ever used those buttons. I'm assuming someone requested them. Copy snapshots to start values. I have used this one. So that button, as the name suggests, copies the snapshot to the start value of the tag. So imagine you're commissioning a machine, you get it right where you're manipulating online values to tweak the machine, get it tuned, get it right where you want it. And then from then on, every time this machine boots up, you want to start with those values. Grab a snapshot, hit the button. One fell swoop, you have set all the start values of every tag in that global data block. So a commissioning exercise. This button does the same thing, but only if that set point checkbox is selected. Way out there. Here. And then load start values as actual values. As the name suggests, it sets every tag in that global data block to its start value.
Like manually reinitializing it.
Yeah, exactly.
Yeah.
And then the button right next to it, it only does that if the set point checkbox is selected. It's a way to filter that button. Again, the only buttons that I have ever I use all the time. This one, obviously, you use a lot. Well, and that one. I have used this one a few times, and I've used that one, I want to say, once. But again, we're not a machine builder. We're more continuous process. I could certainly think, when you're tweaking a machine, getting it up and running, you're commissioning it, these buttons are very helpful.
Are those values, that functionality, again, you mentioned like machine builders. So you get the machine all configured, set up, running perfectly, sitting idle. We now want to snapshot this in case the customer ever really blows it and wants to go back to factory defaults. Is that some type of function that would be available like through the HMI? Can the HMI tweak the PLC to say, hey, move the snapshot or, load this collection that we gathered to set it back to defaults?
So the only way that I would know that you could do that, remember these snapshot values are stored offline with your project, and the HMI doesn't have access to your offline project. But what you could do though, is instead of relying on snapshot, is once you have everything sort of tweaked, you then have another global data block in here that you're calling your golden values or whatever it is. And then there are some functions and function blocks built in where you can move those values into the actual global data, almost like loading a recipe, if you want to think of it that way. The snapshot functionality is really just for you're inside TI portal and you're doing stuff. To do what you're describing, I would do that with like data block copies or recipe values. Great question. Any other questions on the global data block? All right, so that's monitoring tags, that's adding tags. All right, so we've sort of done the tags to death. What if we just want to monitor logic? All right, so here's a question for you. Operations has come to you and they've said, mixed tank sequence stuck in step 6. Can you tell me why? So where do you think you would go to find the mixed tank logic to find out why it's stuck in step 6? Where are we going to go? We know it's somewhere in program blocks.
The sequence is mixed tank sequence.
Thank you. Not a trick question. So if we expand the sequences folder, there is a function block, mixed tank sequence. Let's open it up. Let's see if we can determine why this sequence is stuck in step 6. So double click the mixed tank sequence function block under sequences. Dark blue header. It does not automatically take you online with that function block. Got to turn your glasses on. All right, so let's turn our glasses on. First thing I like to do, if it's logic I've never seen before, let's hit the close all networks button. So which network do you think you would go to find out why it is stuck in step 6?
Number 11.
Thank you. Yep. This really highlights better how important it is to put in these network titles. By closing all those networks, you're getting all that logic out of the way. You can really zero in on where the logic is that you need to look at. Even if it's very, very simple logic in that network, this really shows you why it's important to put those network titles. All right, so if we expand network 11, why are we stuck in step 6? Ladder logic reads exactly the same here as in Rockwell. Green power rail on the left. If the instruction is true, it's green, it's passing power. We can see that the timer is timing. We're sending the accumulated value up to the HMI. All right, we're not going to move to step 7 until the temperature goes above 90 degrees. We can see the temperature is not climbing. So either somebody forgot to turn the steam on, valve 11's in manual mode, something. We can start troubleshooting from there. But main thing to take from this, network titles, and then you read code just like you would in Rockwell. All right, so let's do a real world example here. Some searches and cross references. So operators have complained that they are getting a position alarm on mixed tank valve 12. That's the discharge valve. What steps should be taken to troubleshoot the problem? And what steps would you take in a Rockwell PLC? All right, so the operator knows it's valve 12. They give us that. So how would we approach this? Well, in option 1, if it's a well-documented project, we could go directly to the function block in the network for valve 12, and we've seen that already. We know that there is a folder called valves. We know that there's a function block called mixed tank valves, and we know that there's a network that has SV12 right in the name. All right, we can't always count on that. We can rarely count on that. All right, so option 2, we could search the project, just do a brute force search for any references to the text 0012. Just search the entire project. They gave us that valve number. Let's see if we can go find it. Option 3, we could find the alias, the PLC tag for that IO point, find it in the tag table, use a cross-reference, search for it that way. If we can't find it any way like that, I guess you could find drawings to determine the IO location, which would then give you the ugly tag, which would then allow you to cross-reference back into the logic. Or if you don't have drawings, you could always trace the wiring, I guess, come to an IO card, that gives you the ugly tag. Now we can cross-reference. Options 4 and 5 sound terrible. All right, so we're going to look at options 2 and 3. Let's just do a brute force search, and then let's use cross-references. All right, here we go. So first of all, save your project if you haven't done so. And I want to close all of these windows down here. You can see our editor bar is getting really cluttered. The quick way to close all your windows is to right-click any window and select Close All Other Editors. That'll leave you with just one window open, and then you can close that window with the X. So let's do that. Right-click any window, do Close All Other Editors. And the window that's left open, just hit the X. We want to be back to the blue Siemens gear screen here. All right, so the global search is always right here. Search in project. And they gave us the valve number as 0012. So I'm going to type in 0012 and then hit the binoculars. By default, stop it. By default, the search searches the entire project. Every PLC, every HMI, every VFD. Maybe we don't want that. I really just want to look at the code. I want to watch the logic as he strokes the valve. So I'm going to limit my search here. Instead of searching the entire project, I'm going to deselect the HMI library types. I don't think I have any. It doesn't really matter. And then I'm going to click this devices checkbox right here. That will deselect everything underneath it. I'm going to deselect everything. And then under the PLC, I just want to search the program blocks. So I'm only going to search the program blocks folder in PLC Mixtank. So limit your search to that. And click the green checkbox. And click Start Search. right, this becomes a little more manageable here. So if we go through the list down here, now remember, we're wanting to watch logic. Well, right here, we've got a function block called analog inputs. Oh, it found TT0012. That's the temperature transmitter 12. I'm not looking for that. I'm looking for the valve. All right, so it's not that. I've got two data blocks here. I'm wanting to watch logic. We know there's no logic in data blocks, so that's not it. I've got this simulation function block. That's typically not in a normal project. That's not it. So I've got main OB1, and I've got mixed tank valves. That seems pretty promising. So if I expand that, all right, now we're getting somewhere. So they said when they try to open it, they are getting a position fault. So maybe there's something wrong with the open feedback. So let's double click this open feedback. That'll take us right to this code. We know it's going to take us to the mixed tank valves function block, network 2. So let's double click it, see what we got. So under mixed tank valves, I'm going to double click this open feedback. Turn your glasses on. We want to monitor this online. All right, so here we are, we're monitoring the logic. We're going to ask the operator to stroke the valve from the HMI. He's got it in manual. We ask him to open it. All right, so as we are watching here, we actually see the digital output turn on. And we actually see the valve move off of the closed limit switch. It goes false. But we never get the open feedback. All right, so we know the valve is moving. So we know the output is working. It's coming off of the closed limit switch. But we're never getting the open limit switch. So we really want to check this open limit switch. And as the controls person, we want to check the I/O rack. We want to check the I/O module, look for fuses, look for wire problems. But we said earlier this morning that this %I0.3 doesn't tell me anything about the physical location of this digital input. How do we know where to go look? All right, from right here, I've been promising to show you this. From right here, all you've got to do is right click that tag. Now make sure it's selected in blue. It's got to be highlighted in blue before you right click it. So right click it and do a go to device view. So right click the tag, go to device view. Let's give that a shot. So that shoots us to the I/O rack. Oh, here we are. It's the I/O mixed tank rack. It's slot 1, and it is input number 3. So now we have a physical location where we can go look for this particular digital input. But before you leave your chair, let me show you a few things. Before you actually walk out to the floor and look at this thing, notice the part number of this digital input module contains the letters HF. That means this is a high feature digital input module. Your choices are a BA, which is a basic, ST, which is standard, and an HF, which is high feature. High feature, what that means is we've got the most diagnostics we can get on a digital input module. It is per channel. As you go up from a basic to a standard, I think it's a 10% price increase. And from standard to high feature is a 10% price increase. But I think these digital inputs are probably $100. So maybe you're up to $120 or something like that for the high feature. But let me show you why it's worth it. So I'm going to zoom in here and just show you what diagnostics we get for a high feature digital input module. So for every channel on the card, we're monitoring no supply voltage, right? So bad 24-volt power supply, blown fuse, bad power wiring, short circuit to ground, and a wire break, all wiring issues. We can monitor that for every I/O point on the card. And because the card is showing green here with a green checkbox, that tells us it has passed all of those diagnostic checks. So we haven't lost 24 volts. It's not a fuse. It's not a bad wire, not a wire break. It's showing health. The control system is healthy. So this has got to be a mechanical problem with the limit switch inside the valve. I know it's cliche, but time is money. I'm a big fan of these high feature I/O modules. And what's great is if you do have a diagnostics failure, you can have that particular diagnostic automatically show up on the operator interface. You know, it'll tell them rack so and so, slot so and so, channel so and so, wire break. So the operator has that information in front of him before he ever picks up the phone.
They don't need to bother you at all. I love that.
I don't know that they're going to go out there and fix the wire break though.
Oh, but they call maintenance instead of us.
Oh, okay. Yeah, that's true. Yeah, if you've got a different group that does controls versus going out there and stripping wire and terminating wire. Yeah, absolutely. Okay, so that was the brute force search. Let me show you the cross references. Let's jump back to the mixed tank valve function block. Still open down there. And there's a couple of different ways we can do cross references. So down here in the inspector window, click the Info tab. And the Cross References tab. This is always open down here once you open those tabs up, and it's showing you the cross-reference for whatever tag you have selected up here. So as you click on different tags, you can see it updates. And there's a column here called Access. This lets you know where that tag's value is being changed. If the access is a write, you know that that tag's value is being written to there. It's being changed. In Rockwell, in the cross-reference, they call that destructive, true or false. Same thing here. It's just called access and it's read or write. And the little blue links, of course, gives you navigation to those locations. And what's cool is if I click on this HMI tag here, because the HMI and the PLC are in the same project, it'll even show me where that tag is being used in the HMI. So it's being used on a screen called Mixed Tank. It's being used on a screen called Pop-Up SV0012. So, and it'll take you up. There's navigation to those screens as well. So you know exactly where tags are being used, not only in the PLC, but also in the HMI. The other cross-reference is this one right here, up in the toolbar. And this one behaves more like what you're used to in Rockwell and that cross-reference. So let's click the cross-reference up here. And it brings you just a free form cross-reference where you can type in any tag you want and it'll show you everywhere it's being used. So if I click it, now by default, it's going to show you whatever you have selected down here before you clicked it. It's going to collapse all that. Get it out of my way. And then I can type in any tag that I want to right here. So if I wanted to look for my, let's say, digital input for level switch 13. I can just type in DI LSH 13. And it shows me everywhere it's being used and also gives me the link so I can jump to that location. Tons of ways to do searches and cross references. I'll be honest, I probably use this one 95% of the time. It's a quick way to find stuff. And it's always up there. I mean, it's just convenient. Any specific questions you may have with searches or cross references? How about online edits? And I'm putting online in air quotes because we don't do anything online in Siemens. Operations wants to interlock the steam valve on the tank's lid closed switch. That makes sense. You don't want to let the steam valve open if the operator has the lid open. He may have his head in the tank, or he just forgot to shut the lid. Now you're just flooding the room with steam. So we're not going to let the steam valve open unless the lid is closed. And we've already seen, we've got a lid switch input. We saw that earlier this morning. And we know that the valve already has a built-in input for the interlock. We just need to tie that in. And luckily, we're already in the right place. Sort of. Come back to mixed tank valves. So return to the mixed tank valves function block. Make sure your glasses are on. We're going to try to make this edit online. Because as Rockwell programmers, when we think online, it's start, accept, test, and assemble, or finalize all, starting at version 16 or so. That's not really how we do it in Siemens. So the steam valve is up here at network 1. So scroll on up to network 1. And we can see right now that the interlock is just hard-coded to a true. All right, now we want to change that to the lid switch. All right, so let me show you here, and then you just type it in. We're going to double-click this true, and I'm going to type in DI_LS0011. That is the mixed tank lid closed switch. Type that in, DI_LS0011, and hit enter. I think you'll have to hit enter twice. Let's see what happens. Hit enter, and enter one more time. It took us offline. Got all the orange exclamation points telling us there's a software difference. If you expand the valves folder, if you happen to have it closed, there's the Pepsi symbol. And by the way, if you forget what these symbols mean, if you just hover your mouse over it, it'll tell you online and offline are different. All right, so we know what the difference is because we just made the change. But let's say we didn't. Let's pretend you come in on a Monday morning, you get online with your favorite PLC, and you see this. And you're thinking, okay, what did they change over the weekend? Well, from here, all we have to do is right-click that Pepsi symbol, do a quick compare with online object. So if you right-click the Pepsi symbol, do a quick compare, and then compare with online object. With Rockwell, if you wanted to see what the difference was, you'd have to upload, save it to a different file name, use the offline compare tool to see what the changes are. And actually, if the changes aren't much, they would just automatically upload and you would not really be able to see what the difference was. But here we can do this. To catch up with you here, right click, quick compare with online object. It's going to give us a warning. Hey, you've got that editor open. Is it okay if I close it? We're going to say yes. Now we've got a side-by-side comparison of what's offline and what's currently running in the PLC. Anywhere you see a Pepsi symbol, that's a network that has a difference. And then highlighted in green is what the difference is. All right, so what's offline is our lid switch. What's currently running in the PLC is a hard-coded true. All right, so over the weekend, the lid switch must have failed. They didn't feel like fixing it, so they just said, they need to run. I'm just going to put true here, and they can take care of it Monday. But we need this. This is a safety issue. I really don't want to leave it with a hard-coded true on my interlock. All right, so before we can download, we do have to close this compare. So click the X right here to close that compare window. So we're going to close down the compare window. And then I'm just going to select that function block, mixed tank valves. And I'm going to click download. Is this going to stop the PLC?
Oh,
No. This is a software change. Not going to stop the PLC. All right, so if I click download, notice there's no warning message, nothing in pink. This is just a very simple software modification. You click load. And now we're good. The correct code is now running. I mentioned it earlier today. One of my gripes about AOIs in Rockwell is I cannot change them online. You can do that exactly what we just did there. You can change a function block, download it, not going to stop the processor. That is a software change. You can add inputs, you can add outputs, you can add in-outs. A little more flexible than the AOI on the Rockwell side. Any questions on online edits? Any questions on what constitutes a hardware change or when it would stop the processor? Okay. How much time we got? 15 minutes. Okay, let me show you another just PLC side of things. The HMI stuff is fairly simple. If we don't make it to that today, you'll have a copy of the PowerPoint. Again, click by click, you can add the high-level switch to the HMI. But I want to show you another diagnostic tool that we use a lot. Anybody ever use the Studio 5000 trend functionality?
oh, yes.
Yeah.
All right.
Oh, yeah.
So what do you use it for? Give me a good example.
All kinds of stuff. Sequencing, debug, diagnosing, troubleshooting, ladder logic, looking at process stuff, sensors,
absolutely.
instrumentation.
The trend functionality is a great troubleshooting tool where you're trying to figure out, okay, does this cause this? Do I see what's the timing on this? Does it always follow that this happens? Or maybe you're tuning a PID loop, or it's not a replacement for a trend inside of a HMI or anything. This is a diagnostic tool. And we've got very similar functionality inside TI Portal with something called Trace. So let me show you real quick. Let's skip the HMI stuff for now. I hate to skip diagnostics, but we're going to skip diagnostics for now. We'll come back to it. We're not doing that. All right, trend versus trace. I use the trend functionality all the time as well. Very, very helpful. The one gripe that I have about trend is this. A lot of times I'm trying to catch something that happens at 2 o'clock in the morning, and I really don't want to leave my laptop connected to the PLC online in a motor control center or control room overnight. I'm usually going back to the hotel. I'm working on quotes. I'm working on another project. I really don't want to leave my laptop. And so what Trace actually does is instead of it being done with your laptop, it's actually done inside the PLC. So TI Portal does not have to be running for the trace to be active. Now there's some trade-offs there. You can't collect as much data because instead of writing to a hard drive, you're writing to the memory inside the PLC. But on the upside, again, Portal doesn't have to be running, but you can also get much higher scan rates with the trace than you can with Trend. So what it looks like is you configure the trace on your laptop, you load that trace down to the PLC, and you can pack up your laptop and leave. Go back to the hotel, work on quotes, work on something else. Then you can come back. Now you can leave the laptop connected. If you want to watch it as it traces, you can, if you're tuning a PID loop or whatever, but you don't have to. You can come back the next day, connect your laptop, and see what happened. Also, there's some additional functionality that got added in version 18 called, get to it, long-term trace. Long-term trace is the same as Rockwell's Trend, where you configure it, it scans inside the PLC, but then it all writes back to your hard drive on your laptop, so you can save a lot more data than you can with just the PLC trace. So you got the best of both worlds here. But we're going to look at just the standard trace here. All right, so what we're going to do is we're going to collect data. So the operators have complained, we're not going to be able to do it like that. We don't have the HMI running. Trying to think of a good trigger tag we can use here. All right, we'll figure it out as we go. All right, so we're going to trace the level transmitter and the temperature transmitter, and we're going to collect that data. The trigger tag is going to be that the steam valve is open. Why not? All right, so the operators are complaining that every time they open the steam valve, the level transmitter goes nuts. How about that? We want to see if that's actually the case. They're saying every time they open the steam valve, the level transmitter goes nuts. Let's see if we can prove that out. So there is a folder under the PLC called traces. Expand that folder. And let's double click add new trace. Add new trace. You can see it created it. It just named it trace. You could name it something a little more meaningful, but we'll leave it that for now. So the first thing it's asking us is, okay, what signals do you want me to collect data? So we need something that's changing. Let's go grab glob controller tags LT0011 dot process value, and also glob controller tags dot HMITT dot process value. All right, let me zoom in. So add these two tags to signals. That is the scaled level transmitter and the scaled temperature transmitter. The next thing it's asking us is the recording conditions. How often do we want to sample these two tags? And by default, notice it's going to sample with every cycle of main OB1. OB1, remember how the PLC scans. It reads the inputs, it scans OB1, and then executes all the other code, updates the outputs, does some housekeeping. So we're actually going to see every IO update by doing this. Every 1 millisecond or less. Probably a little aggressive, but we're going to leave it there. And let's go ahead and click the Use Max Recording Duration. So it's going to do 32,766 samples. Sounds like a lot until you think your PLC is only running probably a scan rate of 1 millisecond or less. So that's about 32 seconds worth of data. So if you need more data than that, then obviously you could change this record every 1 cycle to every 10 cycles or every 100 cycles. All right, we scroll on down a little bit. The trigger. When do you want to start writing the data? Now, if you just leave it with monitoring without trigger, that just means you're going to leave your laptop connected and you're wanting to watch the trace as it's happening. You're tuning a PID loop. You're not trying to catch something while you're not there. You know it's about to happen. You can just watch it this way. But if you're wanting to pack up your laptop and go home and you want to catch it while you're not there, we're going to change this to trigger on tag. And what they told us was every time the steam valve opens, these level transmitters go nuts. All right, so we're going to trigger on the tag DI-ZSO 0011. That is the steam valve open feedback. So we're just going to see if the steam valve is opened, does the level transmitter go nuts? Now we could do a pre-trigger if you wanted to see what that thing was doing 100 samples before the steam valve opened, you could do that. And I'm going to leave that at 0 for now. Scroll down a little bit here. Save measurements on memory card. Let's select that. So every 1500 has an SD card in the front of it. It has to be there. It won't run without it. What this allows you to do is all the data that's collected, it'll be written to the SD card. And then you can actually look at the trace from the web server that's built into the PLC. So instead of dragging out your portal or whatever, all you got to do is have a web browser, and then you can look at this trace data to see what happened at 2 a.m. when they open that steam valve. And we're just going to keep one measurement, and then we're going to deactivate the recording. We're coming in the next day. We just want to catch it one time. All right, so we've done part 1 of this. We've configured the trace. The next thing we need to do is we need to load that trace configuration down to the PLC. And we do that with this button right here. So let's click that button. I'm going to download this trace to the PLC. Notice it took us online with the trace. And when you first download a brand new trace configuration to the PLC, it goes down as inactive. To activate it, all you got to do is hit the record button right here. So do that. Let's click the record button there.
Why that's a red circle, I don't know.
Yeah, it's a red circle.
Yeah, just gets me.
Yeah, I don't know. That's a holdback from the tape recorder days, I think.
I always look for like the play button, the triangle.
So now we can see that we're actually looking at the data, but we're not recording any data. It's saying it's waiting for the trigger. Now we could sit here and watch this. Now what you're seeing here, I've got a random number generator that I'm just putting some noise on top of these analogs so we can see some movement. You can see it automatically scaled to the max and the min. If you want to quiet that down a little bit, you can change the min and max scales here. So for the level, we can change it 0 to 100. And then for the temperature, you can change it 0 to 150. That'll quiet down that noise a little bit. So at this point, we could pack up our laptop, go home, come back tomorrow and see what data it recorded. Or if we think it's going to happen fairly soon, we could sit here and watch it and see what happens. All right, so we said when the steam valve opens, so we need to go open that steam valve. All right, well, to open the steam valve, if you remember, we can go back to double-click glob controller tags. That's what the HMI writes to open the steam valve in manual. So let's open up glob controller tags. Interesting, it took me online immediately with glob controller tags. I wonder if that's because I was online with it when I closed it. Notice that? Did it do that for everybody?
Yeah, yes.
Oh, that's a V19 edition. That's awfully nice. I didn't have to click my glasses. All right, so let's hit this button right here. I want to see the trace on one side and I want to see the global data block on the other. This is the vertical pane window. Should show me, I can click it. Here we go. So the steam valve is this HMI SV11. It's in manual, so double click the manual open request. Toggle it on. And so that forces the steam valve to open, and that should take the status of our trace to recording. Let's see if that works. There it goes. 4-second delay in my simulation, and we can see we have now gone to recording. And because the steam valve is open, we can see that the temperature transmitter trace is actually starting to climb. Temperature's going up. Level transmitter is not doing a thing. Not sure I believe the operator. Now remember, this would happen whether we were online with the PLC or not. Again, we wouldn't have to be here. The PLC is doing this work, not your laptop, not TIA portal. Notice it recorded for about 32 seconds. That's the 1 millisecond scan rate of our PLC sim, and then it completed. So this trace functionality works a lot like trend, just with the difference that you don't have to be online with the PLC to do it. And you've got this same trace functionality, by the way, not only in the PLCs, so you got it in the 1500 PLC, you got it in the 1200 PLC, but also the Siemens VFDs have that trace functionality. So if you got something weird going on with a VFD, torque versus current, and you want to see what's going on there, you can actually put traces inside your VFD and have those do that same type of work for you.
Hey, Ron,
Yes, sir.
interestingly, when you created the trace that wasn't there, your little dot there online didn't change to a Pepsi symbol. So it didn't notice it as you added something new, or it doesn't care, doesn't check that.
It almost seems like I've seen something similar where the trace is almost independent of that sort of that program block checking. You're right, because now we've got this green here, but you're right, it didn't show it as a hollow before. And yeah, you're right. I'm not sure why.
Yeah,
Good catch.
We have validated processes, and many times we put diagnostics in there with trends to catch certain things, and it comes up as a difference. So then we have to write memos and explain why
Oh yeah.
finding that the actual processing and product wasn't in any way affected.
Yep, I could see that. Yep, so that's where maybe instead of the trace inside the PLC, you want to go and use the long-term trace. I don't know if that would trigger a delta or not. That would be a good thing to try. I'm actually not played around with the long-term traces. But that long-term trace didn't show up until I think V18. I'm not sure what version you're running, but once that trace data is collected, one of the things that you can do with this button is you can take all that online data and store it in your offline project by clicking that button. So let's click that button, see what happens. Tells us it was added to the measurements folder. And if I come over here, there it is right there. And that will forever be with the offline project until you delete it. And so I can open it up and look at it. It'll show me that same data. So what's nice about that is if you save it with the project, you archive the project, and you send that project to your machine builder, you're saying, hey, the machine's running weird, and he's trying to help you troubleshoot it. So he sets you up a trace. You can save that trace data with the project, send it to him. He can open up the trace and see exactly what it did. If you just want to send the raw data in like a CSV file, that's where this button comes in. You can export the data out as a CSV.
Are these viewable with the web server?
Absolutely. That's one of the great things about the web server. If you know, as long as you select that save measurement to device, I think I've got it on the PowerPoint up here, maybe on the web server. Maybe not. Nope, I don't. But yes, you can absolutely show it on the web server.
Ron, if you just maybe take 2 minutes, go to the PLC properties and show the web server.
Yep. Let's get rid of this split window. So under the device configuration, we did this early this morning, but under the device configuration of the PLC, there's a section here for web server. And by default, this web server is deactivated. You know, it's what they consider, you know, it weakens the security a little bit of the PLC because now you got people that can access things inside the PLC from a web server. And so we can activate the web server on the module. I really prefer to permit access only with HTTPS. And then you can set up through the global security settings what people have access to. They changed this in version 19, or actually through the security settings of the project, you can assign particular users the ability to access the web server. And so you can keep out what people can do. But some of the things that you can do from the, I don't know if that I can actually view it here.
If you go back to the properties in the PLC, under web server, if you break that down.
They changed it the way that you set up the users now.
Okay.
If that's what you were looking for.
Yeah,
so,
there was a drop down or a pull down menu, where I could select everything.
Yeah, that's gone now.
Didn't know that. Okay.
Yeah, so with version 19, you know, they're really trying to integrate the security settings into one area. So used to in some of the older versions, you had a drop down right here where you could assign users and passwords and say, okay, these are what you can do from the web server. You know, flash the firmware, put the processor in stop mode. You know, there's some things, but they wanted to incorporate all of that into one big security area. And so that's where it comes in here under security settings for the project. And so under users and roles, I'm sorry, go ahead.
Yeah, sorry, back where you were, there was a column access. And
Back under here.
Yep.
Just scroll down just a little bit in the web server there. Yeah, yeah, right there, the access column.
That's just for watch tables.
Ah, okay.
Yep,
Yeah,
they changed
really
it.
changed it. Wow.
Yep, they changed it quite a bit. So yeah, now you got to access it through here. It's not quite as, it's not in the same place anymore. Let's say.
Yeah.
Can you use uh, can you browse to a simulated PLC?
Through the web server?
On my laptop, if I brought up Edge. could I-
No, not with the free version of PLC Sim, but with PLC Sim Advanced, yes, you can.
Okay.
That's one of the advantages of PLC Sim Advanced is it does simulate the web server. And that was in my table of differences between. So right here, the web server.
Yep.
Notice the free version, no, but the paid version, yes.
Now I know what that means.
Yep. It's free. They got to put a limit somewhere. I think I actually have, let me see if I've got a web server running on my PLC. Yeah, so this is actually the web server from a running PLC. If I go ahead and hit enter, so I just did this in Google Chrome. You know, it's showing me that everything is okay here at the top level. I can go to the diagnostics buffer. You know, it shows me the last event that happened. One of the things that I really like is this module information. You know, it shows me everything on my Profinet network. And so I've got some ET200S PIO sitting out there. And if I reach over here and I pull out this digital output module, I can do it without breaking it. So you can see I pulled out the digital output module. It's showing me, hey, what happened to the digital output module? And if I go to the details, it even tells me down here, hey, the hardware component was removed or missing. And I can go back to the diagnostics buffer and it'll actually show me again, hardware component removed or missing. So a ton of information from the web server. And, you know, if your PLC happens to be on a network that has wireless access, imagine you're walking around the plant, you've got your iPhone, you've got a tablet, you know, anything that can run a web browser, you have access to all this information just through that device. You don't have TI Portal, you don't have to have your laptop. You know, you can go and you can look at all the diagnostics. You know, one of the things that we do, I don't have it set up, but you've got something called View of Things. Surely I don't have anything. No. Do I? I don't think I did. But one of the things that we could do is we can actually create HMI screens that are stored inside the PLC. There's no way I've got anything in here. No. But imagine creating a very simple HMI with graphics, the same graphics that you have on your HMI for the most part, but instead of having a comfort panel or think Rockwell terms of panel view, you can just bring it up on your tablet through this web server and you can get to the same HMI information that you could from the, for the most part. There are some things you can't do. But just a ton of information here from the web server, you know, communication statistics. Again, the trace view, I don't think I have any traces stored here. I don't, but you could, oh, wait, maybe I do. Oh, I do. So here is some trace data that I actually have stored on the SD card in the PLC. I can view it right here from the web server.
This is, yeah, I mean, this is, as you end users, you know, this is your maintenance guy with any laptop. Plug into the PLC, doesn't need TI Portal, doesn't need to manipulate code or anything, whether you trust him or her, but
So easy, even sales guys can do this.
Yeah, I mean, it can, just connect up, open Chrome, type in the IP address and, they can see what you've allowed them to see here. From a troubleshooting standpoint, most of the time it should get them where they need to go.
And even from the web server, you can grab this data and save it out as a CSV file on whatever device you're accessing it through. And this is not only in the 1500, but it's also in the smaller 1200. You're not doing this in the MicroLogix 800. And what's funny is the price point of the 1200 and the 800 is almost identical, but yet you get all these additional bells and whistles in the 1200 that the 800 you're never going to have. You're just not going to have this kind of access. The topology view actually goes out and analyzes the network and shows you how everything is interconnected on your Ethernet network. Watch tables, again, if you've got any watch tables created, I do. So notice I've got some watch tables here. So if I adjust like my motor temp, I've got a 10-second delay here, but you can see that the motor temp starts to go up. And then my system pressure down here, I can lower it and you can see it actually lowers. Again, it's a 10-second refresh, but you can speed that up if you want to. So just a ton of information you get from the web server. I'm a huge fan of the web server. I enable it almost immediately. Somewhere, if I had set up the... No, I don't think I enabled it. So there was one place where you can go and you actually flash the firmware from the web server. I don't enable that one. That freaks me out. Trying to do a flashing the firmware from Google Chrome over a wireless network seems like you're just asking for trouble. Okay, so yeah, we're up against time here. Any other just general Q&A that you have, something you'd like to see? I'll send the PowerPoint to your distributor there, and they can distribute it as necessary. Like I said, everything in here is click by click, so you can recreate this. Anything that we didn't get to today, like the HMI in particular, the unified comfort panel is such a powerful HMI, and being able to talk to a Rockwell PLC right out of the box is pretty impressive. But then just how easy it is to drag and drop from like the PLC to the HMI. It's worth your time to go through this step by step just to see what you're capable of doing between the PLC and the HMI. The question I get sometimes is, you can do both Rockwell and Siemens. Which do you prefer? And my standard answer is, well, if you have an HMI component, I'm going to go TI Portal. I'm not a huge fan of HMI development, and all the fact that the HMI and the PLC are in the same project really cuts down on the amount of development time there. So I will go TI Portal every time. Also the diagnostics, and we didn't get to that, but just the system automatically telling you on the HMI, hey, you pulled out a digital output module in this rack. The ability to do that with no programming. I don't have to go and I don't have to program a bunch of GSV, get system value instructions like you do in Rockwell. It's just built into Profinet. Any questions?
Unrelated question. Oh, sorry, go ahead. Someone else will go on.
I got a question. What about messaging, like processor to processor? How does that look?
Great question. So that's one of the things that I do cover in the 2-day workshop, but because we're virtual, I didn't cover that. If you're just talking like the message instruction, there is a get and a put instruction that you can do. But if you're talking more like produced and consumed tags, there's something called iDevice. And what iDevice allows you to do is you can add a PLC that looks like an IO device to another PLC. And so now you could just exchange data between the I's and the Q tags. And you can pass UDTs the same way. You just serialize the UDT into a bunch of bytes and send it across IO. And so you're doing it at IO speeds. And if it fails, just like if you lost an IO rack, it would automatically show you on the HMI, hey, you lost communications to this PLC. So your messages aren't going back and forth. But that is something called iDevice.
That's something you can find on Siemens site.
Absolutely. I don't have it in my PowerPoint, but yeah, absolutely. You can find iDevice and pretty much anything. Not that. If you just go to YouTube, you know, there is a bunch of stuff, how-to videos out there on how to do after we watch the commercial. Thank you, Granger.
You said the message.
But this, you know, this shows you, you know, step by step how to do this iDevice between processors. And
You
there
can
are a
also
lot of
do
guys out there that have done this, videos about this. Great question. And if you want to do Siemens to Rockwell, there is a, we didn't get to libraries, unfortunately, but CIP server.
Thanks
So
for bringing that up, Ron. We actually have a couple of people here that are currently using this.
Oh, are they? They're using the CIP
Yeah.
client function block?
Yes. Yep.
So yeah, this is a free function block that you can download from the Siemens website. Notice what they're showing here. They're showing a third-party controller, for example, Rockwell ControlLogix. It's the CIP server. And then you can use the 1500 or the smaller 1200. They can be a CIP client and you can exchange data. And the cool thing about this particular function block is you don't have to make any changes on the Rockwell side. All the work is done on this side. As long as you know the tag name over here, you can read that data back into your Siemens PLC.
Hey, Ron.
You can even write data if they allow it. Good. Go ahead.
Yeah, if you scroll down a little bit, there's a new tool. Keep going right there, that CIP service tool. So you don't even need to know the names or anything on the Rockwell side. If you spin up that tool, it's separate. It's not in Portal or anything. But you point it towards the Rockwell PLC and it goes and interrogates it and it creates a data block for you for TIA Portal.
Wow, so you can just browse to the tags and then select what you want.
Yeah, just used it last week and it was like, wow, this is pretty cool.
I'm gonna have to look at that. I haven't seen that.
Yeah. And if you go to, I think it says it's still in development, so we're not responsible.
Sure.
But yeah, it worked pretty good.
If you can find out where it's the word that's filed, by the way, please let us know. The instructions tell you to go find the file for it. It worked, but I can't find any configuration files. It means that anything went wrong.
Yeah, so there's an installer package. I'm not going to go through that. I'll do that later.
You know, any other applications to where you can go from the Rockwell side to read Siemens, or is that not possible? Besides external, like third-party stuff.
Yeah, there's another one. Rockwell doesn't make it quite as easy.
There is a third-party module. We had the step 7 that was being controlled by a 5000, and it was a different comm module. And as far as Alan Bradley was concerned, it was just remote IO.
Oh, the
Wow, that's
MSP,
impressive.
It's an
the
Ethernet.
multi-field
module.
bus.
You
Is
take
that what
off,
you're talking about?
yeah, something like that. You put it on the front where the CPU was, and now all those IO modules are simply remote IO on the 5000. It was third party though.
Some close-off
So-
thing.
ProSoft.
So then, yeah.
Our good friends at ProSoft.
Yeah.
So this is another free function block that you can download. This is where you can actually, you make changes on the Rockwell side, and then you got a corresponding block on the Siemens side. So you can actually initiate communications here and read stuff from the Siemens, but it requires that you make changes to both. But that allows you to initiate the read from the control logic side, as opposed to always relying on the Siemens to do writing.
And what's that called again at the top on the title? Find that?
Yep.
Got it.
All right.
I had one question here in Malvern.
But Ron, I've experienced Siemens Rockwell, what excellent job of showing how easy Siemens is. Is there anything you prefer from Rockwell?
Is there anything, Ron, that you would prefer to do in Rockwell versus Siemens? I know it's a loaded question.
That's a loaded question. How do I answer this? All right,
I
so
think it seems like it's not such a sales pitch for Siemens. Obviously it is, but I mean, what's just.
All right,
Yeah, what,
so
what's
I'll say
Rockwell do
this.
better?
On the Rockwell side, the ability to add an IO module to a rack and not stop the processor is pretty impressive to me. You know, you cannot do that on the Siemens side. So if I had to walk up and I'm out of IO and I need to add an IO module, in Siemens, I've got to stop the PLC. The fact that Rockwell allows that and we do it all the time without even thinking about it is pretty impressive. I've added a VFD before into a Rockwell PLC and not stop the processor. Thinking about it now, I'm thinking, you know, I don't know what they're doing behind the scenes there that allows that to happen. But then I can't change an XIC to an XIO in an add-on instruction. And that I don't understand. But so yeah, the ability to change hardware configurations on a Rockwell PLC without stopping is certainly something I prefer on the Rockwell side.
I have a question here. Hot swap. Are the IO modules hot swappable?
Yes. So ET200SP, hot swappable. Even the ET200MP are hot swappable if you also use the active backplane modules. But ET200SP is really sort of the main IO that people use. And yeah, absolutely, they are hot swappable.
Which is this? And then the last thing I had, Ron, was, can you show how to archive your projects?
Oh yeah, absolutely. So yeah, if you want to take this project with you when you leave, if you click on Project and Archive, so Project, Archive, the source path automatically defaults to the project that you have open, and then just make sure you look at what the target path is. Maybe you want to send it to the desktop. But one of the things I love about the archive is this checkbox right here, add date and time to target name. You know, if you're one of those people that religiously, I don't know, you want to back up your project often, and you don't want to run the risk of overwriting your last archive. By selecting that checkbox, add date and time to target name, you have no chance of overwriting an old archive. So it automatically adds the date and the time to the file name so that you can keep up with it.
Yeah, creates a unique name each time then.
Exactly. And Rockwell does that with the .BAK extension. But this one's a little more friendly because you can actually see the date and the time, you know, that it was archived. But then just click the archive button. And then you should see it on the desktop. That gets all your HMI screens, it gets all your PLC, it gets, you know, gets the whole project. So now on my desktop, there it is. And you can see the date and the time as part of the tag name. Great question.
Anything else?
Great questions. Awesome.
Good. Well, I think we're good here in Melbourne.
Do you guys have any other questions? Last minute question? Nope. Yep, we're good here in Maryland too.
Well, I sure appreciate you guys hanging out
I have
with us
one
all
more.
day.
Wait, just
Oh,
kidding.
good.
Just
All right.
kidding. Sorry, Ron. We have one more.
Are there any follow-up resources that are free for further training and education?
I'm glad you asked that. So if you want, there is something called TIA University, Siemens TIA University. These classes are free. There is the TIA test drive. Don Wilson with Siemens puts this one on. There's the Merge Logics with TIA Portal. That's the one you just went through, so there's no need for you to take that one. It's the same content. I do it it's the third Thursday of every month. No need to do that one. But TIA the Expressway. So these are videos that I recorded, some simple or quick how-to videos to do some common things. So, if you wanted to update an existing portal project, this is how you would do it to upgrade from like V16 to V17 to V18. Using ProDiag, that's that diagnostic stuff that we talked about where you can generate alarms without writing any code. There's a how-to video for that. One of the cool programming languages that Siemens added was cause and effect matrix programming. If you get process narratives from your customer that use cause and effect diagrams, you can take that directly and program it with this programming language. Multi-user program development. If you've got several people working on the same project, how can you set up a multi-user server, check things in, check things out? That's a good one to watch. Using project and global libraries, we didn't get that to that today, but that's a good how-to video to show you how to do that. So a lot of good how-to videos here that again are free for you to use.
I have that on my list, so I will send that link along with some other links that I made notes of today. I have all your guys' social security numbers, email. So I'll probably tomorrow or Friday, I'll send out a link, a bunch of links, an email with a bunch of links. And then Rod's cell phone number too, so.
Yeah, please. Absolutely. I'll send you my rate sheet. Be happy to. And also YouTube. I mean, anything that you're thinking, man, I wonder if anybody's out there has done that. Yes, they've done that. And there are usually YouTube videos on how to do it.
And last but not least, if you guys didn't know, or you're kind of new to Siemens, Siemens has a US based technical support that is absolutely free for you guys to use. You can open a support ticket online, or you can call the phone number. And they're all done in, well, they could be anywhere in the US, but they're based out of Johnson City, Tennessee.
Yep.
Bunch of great guys. I use them all the time. They're very responsive and they know what they're doing. Know what they're talking. So, Juliet and I will say, maybe Ron, call us first. We're your distributor. We want to help you. That's literally up to my job is, to help you guys. But if I'm not available, if I'm doing Rockwell, the TIA training all the time, I'm not available, whatever. There is Siemens support for you guys as well. And that's free. There's no tech connect, none of that jumbo mumbo stuff. It's they're not going to help you program something, right? They kind of have this unwritten rule that they're going to help you for an hour. After that, then they might want to say, well, we need to maybe look at some paid support or something. But that's why I would,
oh, look at that time.
yeah, that's why I would say get us involved first. Then if it's something bigger than that, we can help influence that. So. But it's there. Sorry, go ahead.
I really like the app. I'm showing it up here. There's the industry support app. You can App Store for app for iPhone, and then Google Play for Droid, and all of these modules. They have these 2D barcodes on them. You scan the 2D barcode in the app, and it'll bring up FAQs. It'll bring up firmware links. Just free to use. It's easy to use. And then again, the tech support number, as we were just talking about, free 8 to 5, Monday through Friday, as long as it's a current hardware or software package. they'll give you support. Don't call about a step 5.
Which they offer support for, but it's paid. You have to pay for it.
Exactly. It's not
Crazy.
current anymore.
Yeah. Super.
All right, guys. Sure
Thanks
enjoyed
a
it.
lot,
Thanks for
Ron.
all the feedback.
Yeah,
Thank you.
Y'all have a good
Everyone.
evening.
Thank you, guys. Thanks, Ron. Great presentation as always.
Thank you. Appreciate the feedback.